Distinguished ladies and gentlemen, Your Excellencies, delegates, friends from the media, friends from all over the world, it's a great pleasure to be here this morning, and we're glad to have your presence for day two and the closing ceremony. On the back of a very strong start, which had been characterized with amazing contributions and perspectives from different angles. And of course, as we go into today,
All right. Yeah, I did bring a few notes to keep it short, but good morning, everybody. We had a really nice recap by ADG Lydia Brito yesterday. This is just a recap of the recap, and because we also have some students joining us today. So these are new audience members, and that's kind of nice to let them know what happened. So is that me? So first of all, I like everybody, I'd really like to thank Ghana and Mexico for their leadership in making this all happen. Now those are governments, you all know that, but and most of us we can't find the power switch to turn on governments to say, okay, take care of the international year. It really involves a lot of people, and special people that are able to do that. Some of them are in this room. And so I'd like to thank all the people that actually made that happen to make it possible for us to work as a team, scientists working with people from the delegations in the United Nations and UNESCO. It really required that. So anyway, thank you very much for that. And thank you, Ghana, for hosting this wonderful event. And I think from yesterday I understood, and I think many of us understood why we are here in Ghana. And I think we got this from, and I forgot his name, the poet we heard from. And that was really a very moving performance, the quantum rhythms, and but also the stories he was telling and the connection between people that he was trying to get us to understand, and the message that he was giving us to take back. And that reminds me, in August we were here with ESDEV Foundation for a wonderful education workshop. And we had David Hutchison from New Zealand who came here and he actually gave a talk. And the secret that he gave about New Zealand's scientific ecosystem was te tahanga, te tahanga, te tahanga, which I just butchered that in Maori language. But it really means it's the answer to the question, what's the most important thing? And the most important thing is, it's the people. It's the people, it's the people. So I had to say it 3 times because you have to get that through everybody's head. But it really is the people, and I think we have to keep this in mind to keep ourselves grounded. So anyway, I heard, that was actually a message that we heard quite a bit. All right, so now, we understood a lot of things. We started out by, the desire was really to raise awareness of quantum science technology, what it can do for us, what it can do to make our lives better around the world, what it can do, just because it's underpinning everything, underpinning our science, but also the technology that drives our modern technological life, our cell phones and everything else. And so it's important that we all understand that. And if I can just add one editorial comment, I think it's, as most of the people here are scientists, and we come up with technological inventions, solutions, whatever you want to call them, but when we start to solve societal challenges, when we start to address societal challenges, I think this was the message I heard yesterday quite a bit. It takes more than just the technology that we're celebrating. It takes the whole society. There's ethical considerations. There's a lot of different legal considerations. You have to build trust in what you're doing. And so I think we really need to talk to everybody, and everybody needs to talk. And that was the message from our poet, and I think it's very true. And so it's something to keep in mind if we want to move forward in an ethical and grounded way. All right, so, and I heard that quite a bit. We also heard that we know that there are many bright people around the world working on problems. What they're lacking is access. They're not lacking often infrastructure. But some of the things I heard were about education, for instance, is that in Ghana, actually, the education is quite advanced. I mean, the idea, the thinking behind how we bring the message to students is quite advanced, and that's really something that Ghana can give to the world. And it reminds me, that we don't want to think about education as filling a pail of knowledge, so just dumping knowledge into students' heads. So and if I was going to quote Yeats, hope somebody from IOP will help me with that pronunciation, the poet, but he said, well, at least he's attributed to saying, that education is not the filling of a pail, but the lighting of a fire. And I think that's the thing we keep in mind, and all the wonderful teachers we have to help ignite that fire in every single student. That's what's going to propel us forward. We need the knowledge, but we need to also light that fire. All right, and we heard that quite a bit. And we heard about from the representative from Cape Coast University about education there, and how there are many practical applications of quantum technologies that improve people's lives, and how that so that gets in the realm of science and society, and I think that again is the same topic, and there really is. So you don't have to look to the quantum 2.0. You can look at quantum 1.0 and see that it's really everywhere in our lives. So I want to take one example, because it's an example you usually use to demonstrate the sort of the time span and how difficult it might be actually to get policy adopted. And the example is a laser. So Einstein did his pioneering work on stimulated emission of radiation, but that was I don't know, 1917. Paul, you're the historian. Okay, but it took 40 years for Ted Myman at Hughes Research Corporation to actually operate successfully a laser. So 40 years from that initial theoretical work to a working device. And the quip at the time amongst the scientists, his companions, his colleagues, was that the laser was a solution looking for a problem. It was just a joke, but nobody could actually foresee what the laser would do. Today, 7 decades later, the progress in laser technology and its applications in almost every single technological sector is mind-boggling. So it really it found the problems. So anyway, that's just a lesson that, and that's where innovation comes in. Not the invention, but to find out where we can actually use these technologies. And I think that's another thing to stress. And finally, really the trust, not in science, but in the way science works. I think we all understood that was brought up yesterday too. That was the critical point where we need to work on within our societies, is to rebuild that trust in the scientific process, which self-corrects itself and takes science out of the realm of opinion and moves it into really our common thought. All right, so last thing, I'll just wrap up here. So we heard a lot about education, I think. We heard about policy from Lydia Brito, and we heard, which is very important, because these technologies are accelerating much faster than the laser did. And so we need to actually ground things ethically and otherwise. But we heard a lot about education and the people. So getting young people to understand quantum science, to be well grounded in the physics, mathematics, engineering, computer science, whatever it takes. And I wanted to, I think that was, okay, so finally, anyway, that was a big issue. And the last thing really the last thing I wanted to say was, it started many years ago, like 2021, and it was a long process to get here. And it looked kind of impossible. There was no straight path forward that we could understand, because we didn't understand how to get to governments. UNESCO can do that, but we needed to get there, and we needed to build it. So this started with the community, and I don't think anybody in the United Nations system would have listened to us if we didn't have the community behind us. And I think having the community behind us to start it was the right way to go in any case. And so it was a long time coming, and to maybe misquote Nelson Mandela, since we're in Africa, who famously said, "It always seems impossible until it's done." That was crossing my mind yesterday all day long. And so anyway, well, thank you. That was just a brief recap and some thoughts of my own. But I think it was a wonderful event yesterday, and I'm looking forward to what we're going to learn and understand today. So thank you very much.
India.
Technology.
From National Accelerator Laboratory.
And I'm from Nigeria.
Quantum City at the University of Calgary.
The School of Computing at Newcastle University.
Tsinghua University.
And I am one of the 100 quantum.
Quantum physics has been described by many words: weird, spooky, magic. But it's not magic. It is just physics, and it is not scary. When you hear the word quantum, I want you to think of the word enabling.
It's about understanding and harnessing the principles of quantum mechanics and technologies that recognize how we compute, communicate securely, sense the world around us, and address complex global challenges.
One of our most important goals is to equip a diverse group of people with the knowledge needed to make informed decisions and to support governments and society in understanding quantum technologies.
At the same time, as the field grows, there is a real need to make education and training more accessible. My focus is on teaching and building communities in Mexico and across Latin America, helping more students and institutions get involved so the benefits of quantum technologies reach the wider global community.
Profound scientific breakthrough, like landing on the moon or building the James Webb Telescope, only happen when you work together. And quantum science is the next chapter of that collaborative story.
At the end of the day, quantum has the power to reshape critical infrastructure in Africa, but its impacts depend on who gets to build it. And I absolutely believe, that the future of quantum will be defined by whether Africa is empowered to experiment, to innovate, and also lead in this quantum space.
I have no doubt that quantum technologies like quantum communications and quantum computing will enable a better world, but only if we, not just physicists, work together, because quantum is for everyone.
Ladies and gentlemen, we'll now invite Paul Kadden-Zimanski, who is an associate professor of physics at the Bard College, to give us some more perspective to this. Shall we do a big round of applause as he mounts the stage?
So the United Nations Declaration of the International Year stipulated that the goal, or a primary goal of the year, was to help the entire world understand the importance of quantum science technology. And if you think about it, the task of saying we want to help the world understand blank better, we could have hardly picked a more challenging topic than quantum mechanics and quantum science. It's a very challenging thing to try to explain, to try to get people to understand. One of the barriers to understanding, the first barrier is for people to say, you know what, I've heard of something like that, and I can't, I'm not the type of person who could learn about that. And we really wanted to encourage everyone around the world to think to themselves, it's possible for someone like me to be able to understand the importance of quantum science technology. It's possible for something like me to contribute to this. And Joe talked a little bit about the physical and technological history of quantum science technology, but there's also the human history of it, right? That it's a theory and ideas that started in one region, one place with a few people, but over the past 100 years, it has spread out to the entire world. And we really wanted to show the entire world, all those people who thought, that's not me who does that, that's somebody else, that there are all these different people from all walks of life working on quantum all over the world. And that was part of this Quantum 100 initiative. So the 100 people selected to be part of the Quantum 100, they're not winning a prize or an award. The role that they were playing and that they understood they were playing is being 100 faces of what's happening around the world right now. So that mission, I think, is one of the most important of showing people, hey, you could be this person as well. People like you are doing this. I'd also add to mesh together the technological and the human, that if you think about how that video was made, we sent out emails and had people record videos on cell phones, things like that. All that technology, right, coming down to the laser, the transistors, relies on quantum science to some degree or other. So it was only by using the technology of quantum science that we could show people what the world looks like today in terms of the faces of quantum science technology. And I think in the discussions yesterday about putting science to good use, right, the flow of information can be put to all sorts of uses, but showing people what is possible, showing that they can be part of this, that was the purpose of the Quantum 100. I wanted to end by saying a couple of thank yous, because the Quantum 100 initiative was just one of many initiatives that happen around the world. But two people who did the heavy lifting behind the scenes really deserve our thanks for working on the Quantum 100. One of them couldn't be here today. Emily Edwards is a member of the steering committee, so I wanted to acknowledge her. And the other person is Claudia Fracciola, who many of you know was an engine not just behind NIST, but behind the entire year. So I wanted to give her a warm round of applause.
To you, Mr. Paul Zemansky. Ladies and gentlemen, we're starting off with our very first panel discussion for today. The topic is exploring the strategic priorities that will define the next decade of quantum science and technology. Our moderator for this session is one who is a particle physicist who has served as a leader of scientific organizations in the United States of America and Canada. He earned a bachelor's degree in physics and mathematics from Harvard, and also a master's degree from Cambridge, and his PhD from Princeton. After postdoctoral fellowships at SLAC and IAS in Princeton, he joined the faculty of Harvard and then Johns Hopkins, where he later was appointed the Krieger Eisenhower Professor of Physics and Astronomy. At Hopkins, he served as a department chair and vice interim provost. And in 2014, he was appointed the director of Canada's Particle Accelerator Laboratory in Vancouver and a professor of physics and astronomy at UBC. Then he moved back to the United States in the year 2021, became chief executive officer supersymmetry, and supergravity. He's a fellow of both APS and AAAS. Distinguished ladies and gentlemen, please help me with a big round of applause to welcome here to the stage our moderator, Jonathan Bagger.
And to help the moderator do justice to the topic is Lydia Atta-Brito, Assistant Director General for Natural Sciences on 2nd November 2023. She has been Assistant Director General for Natural Sciences and ad interim since June 2023, helping to formulate innovative responses to contemporary environmental challenges. A forest engineer with master's and doctorate in forest and wood science from Colorado State University, she was born in Mozambique and has been part of Eduardo Mondlane University staff since her graduation in forest engineering in 1981. She has held senior positions in Mozambique, such as head of the forestry department from the Faculty of Agronomy from 1997 to 98, vice rector for academic affairs of Eduardo Mondlane University 98 to 2000, Minister for Higher Education, Science and Technology 2000 to 2005, an advisor for strategic planning and external relations of the Mayor of Maputo City 2005 to 2008. She joined UNESCO in November 2009 as Director for Science Policy and Sustainable Development in the Natural Sciences sector in Paris. And in 2014, she was appointed UNESCO Regional Director for Sciences in Latin America and the Caribbean region. In 2022, she began Director of the UNESCO Multisectorial Regional Office for Southern Africa in Harare, Zimbabwe, and UNESCO Representative for Botswana, Eswatini, Lesotho, Malawi, Mozambique, Namibia, South Africa, Zambia, and Zimbabwe. Her areas of expertise range from forestry and sustainable management of natural resources to higher education, science, technology, policies and programs as part of public policies for sustainable development. She has chaired several commissions and task teams in higher education, STI for sustainable development. Madam Brito, thank you. The next is Sylvina Pons-Dawson. Sylvina Pons-Dawson, a professor of physics at the University of Buenos Aires and a senior researcher at CONICET, Argentina. She currently serves as the president of the International Union of Pure and Applied Physics, IUPAP. Her research focuses on biological physics and nonlinear dynamics. Throughout her career, she has been a tireless advocate for gender equity in science and has led international efforts to measure and reduce the gender gap in physics and mathematics globally. And Sylvia, if you are here, you are welcome. The next is Amadou Wag, a professor of physics at the Université Cheikh Anta Diop in Dakar, Senegal, and serves as the president of the African Physical Society. He's a leading figure in the promotion of optics and photonics across Africa. He's the founding president of the Africa Laser, Atomic, Molecular, and Optical Sciences (LAM) network. His leadership is focused on building Pan-African scientific infrastructure and ensuring that African physicists are integrated into the international quantum and light-based research communities. Professor Wag, you're welcome. The fourth is Tommaso Calaco. He's the director of the Institute for Quantum Control at the Peter Gromberg Institute of Forschungszentrum. Forgive me if I messed it. Jules, and a professor of the University of Cologne. He's widely recognized as the architect of the European Quantum Flagship. He authored the Quantum Manifesto, which initiated the European Union's massive investment in quantum technologies. His work is central to international quantum policy, focusing on both the technical development of quantum control and the strategic coordination of global quantum initiatives. Thomas, thank you. The last but not the least is Dave Alsobrook from ST Quantum. He will join us online. Thank you very much.
So I'd like to just start by thanking Joe for the really masterful summary of yesterday, and also Paul and the entire Quantum 100 team for really showing us the faces of the future of quantum science. So today, what this panel will focus on that future, and in particular, how together we will build that just and inclusive future for quantum science. And so with that, I will sit down and ask my first question to Lydia. So Lydia, UNESCO views IYQ as a catalyst for global sustainable development. So as you look towards 2030, what is the most critical factor that will help determine whether the benefits of quantum science are shared globally rather than just concentrated in a few countries? Thank you.
Thank you very much, and again, good morning to every one of you. I think the decisive factor is when quantum science and technology is seen as a global public good and not just a strategic asset. And I think throughout yesterday, we discussed quite a lot of the importance of access to the technology, the education. And for UNESCO, I think there are three major areas that are critical in order to really achieve the benefits, the full benefits of these technologies to everyone. And the first one, of course, is capacity building. And yesterday and today, Joseph, you mentioned quite a lot the importance of education, of capacity building, and that it's something that UNESCO has put in the front run of the International Year, as you well know. The second one, it's cooperation. Again, yesterday and throughout the International Year, what we have seen is the more people collaborate with each other, the more advances we can get, and the more benefits can be distributed to more people. And I think scientific cooperation is such a huge topic today because we are seeing a retraction on that. We are seeing less mobility of researchers, of scientists. We are seeing less joint programs. And so scientific cooperation will be key to continue this momentum. And finally, again, very much highlighted yesterday, and His Excellency the Minister of Education mentioned that, is the anticipatory governance. We have seen that with emerging technologies, if we don't look at governance issues from the outset of the development of those technologies, what we see is inequalities. And really, we need to continue to work throughout the years to come on that. We really believe that quantum science can address global challenges, but to do so, it needs to belong to all of us. Thank you.
Well, so thank you very much for setting the theme of this panel really so clearly. Now I'd like to turn to Tommaso. The European quantum strategy balances technical sovereignty with international collaboration. And so as we move into the next decade, I'd like to ask how nations can protect their legitimate strategic interests while also lowering barriers towards global scientific collaboration.
Well, the zero-order approximation is they can't, sadly, in the sense that we must expect that, unfortunately, and here my heart as a scientist is bleeding, thinking about that, you know, these considerations of strategic sovereignty, which nowadays, due to recent developments, so the world is no longer a globalized order. So it develops into a multipolar order. Maybe it's a multipolar disorder, you know, if we look at it in psychological terms. But anyway, so the thing is that some unwanted consequences will be there. We will not be free, unfortunately, to exchange as much as we want, as much as we have always done, as much as it is necessary for the future. However, there are things that we can do as a scientific community and as governments to reduce the impact of that. And of course, this is about focusing, distinguishing between low technology readiness level, low TRL, fundamental stuff, which should continue to be as open as possible. And I think this is uncontroversial. The trick is finding the balance, drawing the line, which is far from trivial. But it is possible to argue for that. And higher TRL. But on the higher technology readiness level, I think that there is also hope that we should keep the door open, because there are a lot of challenges, and Madame Brito mentioned that yesterday beautifully. The quantum divide is something which is going to be prevented in everybody's interest, not only in the interest of the less advanced countries, but also in the interest of the strongest countries with the strongest investment. It is in their egoistic interest that the quantum divide does not take place. And this requires inherently also to address as much as possible access to infrastructure, cooperation, also on the higher TRL. So we should stress the points of advantage for everybody for cooperation also on the more advanced TRL levels.
Well, thank you. That's exactly the issues. Those are exactly the issues the APS is struggling with these days. And we are, I think, firmly on the side of that basic science really is a human good for all. So now I'd like to turn the floor to Amadou and ask and focus more now on Africa, and actually ask how must our partnership models evolve so that they leave behind a lasting infrastructure and leadership position within Africa.
Like to thank. First of all, I would like to thank American Physical Society and John Berger for an invitation to be here in Ghana, the country of my heart, and the country of Professor Alote, the founding and first president of African Physical Society. So, answering to your question, I think that the most important key pillar will be education and human capital development. And for education and human capital development, we need a strategy for that. And the strategy is first the curriculum development and integration in university by introducing or by continuing quantum science fundamental at university level, including physics, computer science, engineering program, and also specialized quantum courses in university. In graduate program, we have to establish MSc, PhD program, quantum technology in leading African university. Capacity building to offer scholarship, fellowship, exchange program. We've established quantum center worldwide, in Europe, in USA, in Asia. And one other thing which is important is the STEAM outreach. This is extremely important in Africa to promote quantum literacy from kindergarten, as somebody said yesterday, to primary school, to university, everywhere. And this is extremely important. And one of the important things for doing that is to make free basic education for all the African children. Because, now in Africa, most of population are young people. We have about 75% of population, less than 25. And the children, many children are not going to school. We have to extend school, free school to everybody, to all the children. Because if you don't do that, we cannot get engineering in quantum science, in any kind of science. This is extremely important. And one other thing is to have a training center to create a regional training center in quantum training center, which are focused both on theory and experiment. And for that, we have to prioritize area in quantum science, which are quantum communication and cryptography, quantum sensing, quantum computing for agriculture, climate modeling, and finance, and also for energy. Thank you.
Well, thank you for that really incisive analysis of the situation in Africa. It's actually not so different in many countries where we struggle to get a range of people into the science ecosystem, into the quantum ecosystem. And that's one reason why I'm so happy that there's students here today witnessing us. Of course, education, as you pointed out, is much more than a PhD. And so I'd like to now turn to Dave, who's online, who can talk a little bit about how South Carolina in the United States is trying to build a quantum, people-first quantum economy. And he can comment on how they are working to ensure that the full spectrum of talent, including technicians and engineers, can be brought into the ecosystem, as well as the PhDs. Because I suspect many of the lessons from South Carolina apply much more broadly. Dave.
Well, first of all, thank you for having me. It's really an honor to join such an esteemed panel there and event. When we talk about building a people-first quantum economy in South Carolina, it really, I have to say this up front and be clear, we didn't really start with a perfect blueprint. What we started with was a belief. And from the beginning, our mission was always to champion not only the technology, but the people of our state. I sense a theme in the event. We believed early on that unprecedented collaboration, as we call it, across education, industry, and our communities, that's what would shape our quantum future to be more inclusive, more dynamic, and ultimately more useful to our residents. And that belief is really what shaped our approach in South Carolina. So when we began, we asked what industries already exist here in the region that can benefit from quantum. And this is really an exercise that anyone can undertake wherever you are. And what it offers is a faster track toward implementation rather than waiting to build entirely new industries around emerging technologies once they're viable. Now, some of the questions, they're always going to be answered at the university level, of course, at the doctoral level. That research is completely essential. We know we need it. But from the beginning, we always emphasized applied research as being the bridge between the discoveries and the real world use. And that approach really works in two directions. So on one end, you have research informing the applications of the technologies. So students and researchers, they're exploring quantum methods, in our case, like optimization and finance. And that begins to shape how the industries begin to think about these future tools. And we had faculty and industry learning series with our technology partners, and those really helped to just align all of the possibilities across the region. Now, in at least one case for us, this led to an early stage venture, and it was our state's first quantum startup. We're very proud of it. And it was some finance students in school who founded it, and ultimately they chose to stay in our region in South Carolina once they graduated. Now, at the other end of the spectrum, we have outreach and education, another theme I sense. And we tried to move that further upstream. So we engaged our educators, the technicians, engineers, and of course our younger learners, our quantum citizens to introduce these quantum principles without requiring or really the pressure of full specialization. Just tried to get them early. And this includes things like developing an online education platform for middle schoolers and high school students, or bringing in hands-on tools like robotics to elementary schools and middle school classrooms. As many of you know, the key here is that experiential learning is very critical. And the result isn't just a simple pipeline for the economy. It's more of a dynamic landscape or ecosystem where learning and research and application all reinforce one another. So we have technicians and engineers. They enter the conversation earlier. We have students who see multiple pathways forward in the technology. And importantly, the quantum development that's taking place, it stays connected to the economic and even the social realities of the region that it serves. So when we talk about these inclusive quantum economies, we really mean it when we say today it's not really primarily a technology challenge, it's a design challenge for us. So we need to ask, who can we invite in? How quickly can they join us? And can we make collaboration more of an essential rather than an optional component of what we're building? Now at South Carolina Quantum, we've completed our convening mission, but we think that the framework is one that can serve any region. So thank you.
Thank you. I do think it's clear that South Carolina's inclusive approach really applies more generally. One other component of that ecosystem are the parents, because when a student comes home from school excited about science and tells their parent they want to become a quantum scientist, most people will say, oh my God, you really need to get a job. And I think making it clear to parents that there's actually a career of one sort or another in the quantum world is probably very important. So now I'd like to ask Silvina, here representing IUPAP, a group that monitors the health of the global physics community. Now, it's long been noted the flow of talent from the global south to the global north, but I'd like to ask you what we could do to reorient that a bit so that it becomes more of a circulation of talent as opposed to a permanent migration of talent.
Thank you for the question. Before answering, I just want to remind you all that today, February 11th, is the International Day of Women and Girls in Science. And the gender gap in STEM is still something very real. And I think it's a job of everybody to try to reduce it. So I didn't want to forget that date. Okay, so let me go to your question. One thing that I think it's important is to avoid what Yasser called the colonialism, the scientific colonialism. It's good to nurture the development of communities, local communities, but then it's their own job to set their own agenda and eventually put some funding also into science. So we can try from the international community to help, to act as a seed to get things growing, but at some point it's also the local communities that need to develop themselves and set their own agendas. So there are a bunch of ideas here. The first one I could think of is a funding to organize schools and workshops for graduate students, for example. There was a very interesting example in the past funded by NSF in the US, which was called Pan American Advanced Studies Institute. It was a line of funding to organize schools and workshops in countries of the Americas with professors from the Americas and elsewhere. And that's very good to develop the community and develop new relationships. Then also funding for networking. There is another example also from NSF, which is the Physics of Life of Living Systems, which is a network to help students who do research in biological physics to connect with one another. And there are conferences for them to expose, and there is money for them to go visit other labs. So promote networking and visits. Then shared infrastructure of different types, large infrastructure, of course. And then there are different options there because on some occasions people have to go to do their experiments there, like with synchrotron light facilities. In that regard, IUPAP, together with the ICTP and also IUCR and other unions, they have a project that is called LAMP, Lights for the Americas, Asia, Africa, and targeted regions of the world, to try to develop the community of users of synchrotron light facilities. And this is done mainly through the funding of travel grants for teams of students and teachers to go visit the facilities and know what can be done. I think that that's another option. A joint PhD programs with double degrees, that's another option. And two more things I want to mention is, please don't avoid organizing conferences in the Global South. I know that there are concerns about CO2 emissions and going massively to the Global South, but nothing replaces the face-to-face connection, and I think it's important to keep that. And another thing that I think that has to be rethought is the open access program of journals and stuff, because it's pretty much unaffordable for many countries. So we want to share knowledge, but we have to think of something that is available for everybody.
Also, thank you. That last point about open science is super important, and we've been hearing about it for a while. It's certainly connected to the International Year for Sustainable Development, or the International Decade, I guess now, in fact. And but maybe open science isn't enough, and so I would like to ask Lydia to speak a little bit about the idea of open infrastructure, which would barriers to infrastructure as well.
Thank you very much. You know, the open science recommendation of UNESCO already promotes open infrastructure. So the open science perspective for us, it's also open infrastructure. And really, in today's big science, you cannot afford to have infrastructure that is only for you. You will not be able to fully use it, and it will be sooner, out of date. So really, doing open infrastructure by joining efforts and building joint infrastructure is the smart thing to do, because you can use it fully, pay for the cost of investment, and keep upgrading that. If you do it by yourself as a country, as an institution, you are going to lose the battle, and you will be outdated very quickly. So it's part of the open science recommendation of UNESCO to really promote open infrastructure, and the European Union for many decades have done so very, very successfully, and I hope many other countries, in particular in the Global South, will do so. For example, UNESCO has promoted Sesame, the synchrotron for the Middle East region, and this is the only way they could afford to have these facilities, to have all these countries, even countries that don't collaborate diplomatically, that are even in war, they can still use because they are members of the same scientific infrastructure. And I think this is also another way to promote scientific cooperation. When you share infrastructure, you can collaborate fully because you are there, you bring it together. But clearly, your question is about what does it mean for quantum scientists really the access to hardware, and how much is that a barrier for making sure that all countries have access? And I think very much linked to some of your answers. One program that we have, and we have been using also for quantum, is what we call access to remote access to laboratory facilities. And that fights brain drain, because the program is a very simple concept. You have institutions with a lot of capacity, research infrastructure that can be accessed remotely. So we train researchers from laboratories where they don't have that infrastructure, and then they remotely access that infrastructure. And the beauty of this is that you not only create capacity on that researcher, but also his team or her team will be also capacitated, because they will participate in the experimenting by remotely accessing the infrastructure elsewhere in the world. And that really, it's about talent and not geography. If you have the talent, you have access to the infrastructure. And also the other thing about this initiative that I'm really, really very proud, and of course, Amal and Chofeng are the team that are putting it in place, is that it's also about scientific collaboration. Because although I will assess the equipment remotely, I still need a peer at the other side, to help me to put my samples, to make sure that the equipment is ready for my use. And so again, you can find creative ways, and technology today helps us to do so, to really, really promote collaboration, to promote capacity building, and to promote access. Coming from Africa, I always say to people that talk about freedom of academics and freedom of research, and I always say that the first freedom that is taken away from African researchers is the freedom to do research in Africa. Because we don't have the funding, we don't have the research infrastructure, and many times we don't even have a career in sciences in our continent. So this is something that we really, really need to continue to push forward, and I believe the next section will be on the global Quantum initiative that UNESCO is proposing to continue and build on what we have done during this international year. And part of it is really, really to make sure that every single researcher can do research on quantum in their countries, in their continents, and really build the capacity, the critical mass that we need to use well the potential of quantum. Thank you.
Well, thank you very much for that powerful statement. You brought up Sesame, the lab in Jordan, that is really just a miracle, in my opinion, of the role that science can play in bringing people together. And if you've never heard about Sesame and you're in the audience, Google it and just look at the amazing number of countries behind it. Well, CERN as well, but especially in my mind, Sesame. And also ICTP, Sandra, over there. Yes, you play a very important role of providing that infrastructure that helps people connect. So I'd like to turn the question now to the young people in the Global South. And so, if I'm a young person in the Global South and I have a great idea, what is the most immediate gap that needs to be filled? Is it access to funding or mentorship or equipment? And so I'm going to ask both Amadou and Slovenia, representing Africa and South America, to take a crack at that question. Amadou.
It's working? Okay. I think that the most important thing to do for Africa is not competition to build a first computer, quantum computer. It should be a effort to build strong partnership, regional partnership, and global partnership and collaboration. And the future for African quantum science is about strategic participation in a secure communication, in energy system and material, in climate modeling and Earth observation, in health, agriculture, and logistics. And for that, there is a condition, a necessary condition. And this necessary condition is a sustainable funding and investment, political will and policy support from African governments, integration and education of research and industry, strategic international collaboration and focusing in problem relevant for Africa. This is what I think.
Thank you.
So I think that the bottleneck is mostly funding. And at least I think that in most Latin American countries, there is a huge separation between universities, the academic world, and the more private sector. And there is not that much of it's not so common to have startups and stuff like that. So there is not a culture of that. It's changing. Of course, it depends. It depends on the country, and even it depends on the region within the country. But that's what I think it's slowly changing, and mainly now it's changing with things related to data science and AI. I think there is, with the new generations, is changing. But I would say that funding, seed money for startups and things like that, that's what's mainly lacking there.
So building that connection between the university sector and the private sector is something that Dave spoke to us about. So I'm now going to throw a question to the entire panel. Might not have time for everybody to speak. Dave, I can see you a little bit. So if you have something you'd like to say, raise your hand so I can see it. So and this question is one that actually interests me quite a bit, and it's really circling back to what you raised at the beginning, Tommaso. There is a natural tension between scientific openness and national security. And so what is one actual thing that we can do to ensure that basic science is free to flow between countries across borders? And anybody can jump in, but you're welcome to start.
Well, we should be doing what we are doing here and what we do all the time, which is what Paulina said before: traveling, meeting people, being there, keeping all those connections alive, developing projects, not just going to conferences, but, cooperation in terms of joint activities, joint things that we do, writing papers. So what scientists do, what we have always been doing, it's keeping those doors open. Even in the coldest of the Cold War. Actually, now it's in some respects even worse than at that time, because even the coldest of the Cold War, there were still, clear exchanges, unlimited, unrestricted between, the blocks. And now it's getting even worse than that. So all that we can do, what we are, paid for, cooperating, developing ideas, writing papers, exchanging, that's the most important thing that we can do. We are among the few communities which can still do that in a harmless way, I could say, okay, because it is not a threat, pursuing knowledge, and still it's almost understood, let's say, also at political level. So we should just strongly continue doing that. That's the most important thing that we can do. Like, you have to light the flame, we have to also keep and guard the flame.
And that's something the APS is working on very hard. We view it as really central to our mission. Lydia, did you have a word?
Thank you. Maybe just building on what Thomas said. That's why UNESCO is here. That's why we exist. It's our convening power. I remember, and maybe John, you also remember the comments from the participants last year when we launched the International Year of Quantum Science and Technology, that at UNESCO they could meet and be free to talk. And I think this is our role. And UNESCO was created after the Second World War. That's why I mentioned CERN. CERN was created because there was this danger of sidelining German scientists from the rest of the European communities. We needed to find a way of bringing the scientific community together for the rebuilding. UNESCO stands for Education, Science, and Culture for Peace Building. That's part of our mandate. And like Thomas said, that's why we are here. That's why we have international years. That's why we have international decades, because we can bring the scientific community together. We can do remote assessing, we can do joint seminars, thinking together, and fighting this idea that scientists should not talk because the countries have no political or diplomatic relationships. This is when scientists should talk more. The more divided the world is, the more we need scientists to stand together, because it's about finding solutions to build a lasting peace. And lasting peace is the people to live better, everyone. If the rights, their rights defended, their lives better, and their ability to choose, as you said, to choose their lives the way they want to live. And this is why scientists are so important for humanity, for the planet, and that's why we have such a big responsibility not to give up. We need scientific cooperation.
Bravo, bravo.
I wanted to add something. In IUPAP, we have this motto, which is scientific collaboration is a driver for peace. So we always work to bring people together, although their countries might be against one another or something like that. So, and facilitate the global cooperation.
So I hear from this panel basically the unanimous opinion that bringing people together is the important thing that we can do. Now, I was given this note here which told me to wrap this up. And so I'm going to skip to the very last question. And it's a question for each of you. And I'd like you to finish the sentence I start. And notice I said sentence, not paragraph, not page, but sentence. And we'll start with Dave and then just go right down the line. Is that okay? So for the International Year of Quantum Science and Technology to be truly transformative, by 2030, we must have successfully addressed what?
I'll try to set a good precedent and keep it to a sentence. So for the International Year of Quantum to be truly transformative by 2030, I think we have to figure out or address how quantum is going to move from promise to practice for everyone. And really the biggest question is who gets to be a part of that journey?
Thank you. Maso.
The quantum divide. Sorry, it's a repetition, but that's really the most important risk for the future.
It is to build a strong partnership, regional and global, for the development of quantum science.
Thank you.
This one? Okay. Two things, actually. I think education. I wish that there is a change in the curricula of most STEM careers to include quantum in the curriculum, which it's not now, and also quantum literacy. So I think those two aspects are the ones that would be very transformative.
Thank you. And Lydia.
For me, again, two things. The first one is that the development of quantum science and technology should be based in the talent, not in geography. So we need to involve all the talent, young people around the world to advance this scientific field and this technological field. And the second one is that through awareness, through quantum literacy, to make sure that all benefit from what this scientific field and technological development can bring to better the lives of everyone. Thank you.
Well, I'd just like to really express my deep gratitude to the members of the panel for sharing their thoughts. I think there's really quite a bit of unanimity in our view of the importance of education and migration, the circulation of talent, the sharing of infrastructure, and really that the equator is just something that's on the map and not something in reality. And thank you to audience for listening. And with that, we'll close this session. Thank you very much.
Conversation. We'll now take a message from one of our sponsors representing Frontiers Media of SA in Reading, UK. And I'd like to bring here onto the stage Rolly Richer, who is a journal manager at Frontiers Media SA. Shall we do a big round of applause as we welcome her?
Good morning. I hope we have all got some rest and the energy back after last panel. And frankly, it has set us up for very much of what Frontiers does. So today, we are watching a global ecosystem form in real time. And as the journal manager for Frontiers in Quantum Science and Technology, I've more or less had a front row seat to a spectacular year and some great sessions since yesterday. It's a scientific community which is choosing collaboration over competition across borders, across sectors, and across disciplines. So that has been amazing. And first, on behalf of Frontiers, I would like to thank everyone who made this International Year of Quantum not just a celebration, but really a global effort to shape the next century intentionally and responsibly. This year has reminded us that progress is richer when more people can be involved in it. Yet, we see a huge challenge at the very foundation of participation: access. Access to quantum knowledge. Even today, more than half of world's scholarly outputs still remain behind paywalls. And in the field of quantum, it's upwards of 60% of this knowledge. And this is really striking, especially for quantum science, which at its heart is entangled. So too much of our shared knowledge is still remaining siloed, and it's just because of the access. And the cost of access isn't just inconvenience. It's slower verification, fewer interdisciplinary bridges, and fewer chances for a brilliant mind anywhere in the world to be able to contribute to this. So at Frontiers, our mission is to accelerate science by making it open. Open to read, open to build on, and open to the widest possible community. We are guided by a broader purpose, which is enabling healthy lives on a healthy planet. Quantum science will be a part of that story, be it through quantum chemistry, quantum biology for vaccine development, quantum computing for climate models, and so on. A lot of it which we probably haven't even named yet, a lot of those applications. But in the end, the benefits can't be shared unless the knowledge is shared. And I would like to thank especially Silvina and Lydia Brito, for your comments in the last panel, because that has been very encouraging towards how we are moving towards open science and open infrastructure. And this year, at Frontiers, we spotlighted a breadth of quantum research in openly accessible formats through some collections, which is spanning several of our journals. And these journals aren't just symbolic, because we are seeing thousands of people engaging with this on a regular basis. So it's a clear sign that if there's a real demand, and when barriers are removed, there'll be more access and more engagement of this quantum knowledge. We are very proud to share also a newly launched flagship ebook that we have, around 100 Years of Quantum Science. It's free to download on our website. We do have a few printed copies as well you can pick up from us, or scan the QR code to be able to download and access this. This is meant to be a community asset, open access resource from several experts in the field. And we have also worked towards making quantum this year travel a little bit further into the rooms where long-term decisions are getting made. Last month in Davos, during the annual meeting of World Economic Forum, we launched the Frontiers Science House. It's a platform designed to bring scientists together with the industry leaders and policymakers for agenda-setting dialogue. It is vital that the science is in the room where the global strategy is set, because the next quantum century will be shaped by how we fund science, how we govern it, translate it, and make it accessible. So, as we close the International Year of Quantum, my ask is pretty straightforward. Let's celebrate with real pride what this year has represented, and then go further and increase the connectivity of our ecosystem. More open research, more shared infrastructure, more global participation, and more dialogue across our shareholders. If we want the next century of quantum breakthroughs to serve humanity, then the knowledge behind those breakthroughs has to be something that the humanity can actually access. So thank you, and congratulations to everyone who made the International Year of Quantum such a global celebration of quantum science. And may the legacy of this year be a commitment that quantum knowledge is accessible, reusable, and directed towards the well-being of the people and planet. Thank you very much.
Ladies and gentlemen, at this time, we'll zoom in on our second panel discussion. This will be on the topic, production and launch of the global quantum initiative. Helping us to delve further into this, I'd like to introduce to you our very seasoned moderator who's also been here with us from yesterday. He's helped me a big round of applause as we welcome here. Mark Kasri, basic sciences, research, innovation, and engineering at this
former Deputy Minister of Communications and Information Technology, former Director National Telecommunications and Publications, International Telecommunication Union, Geneva, Switzerland, former Cultural Counselor and Director of the Educational Bureau of the Egyptian Embassy in Canada.
Thank you. A big round of applause for them, ladies and gentlemen. And now, before we start off a panel discussion, we'll have a brief message, introduction, and the launch of the Global Quantum Initiative. This is the Director for Division of Science and Policy and Basic Sciences at UNESCO. Please help me with a big round of applause to welcome Shafet.
vibrant platform, and we already reached some common understanding about how the global quantum science should be conducted, how we can organize ourselves. And we have the platform, we built a partnership for the investment and for the implementation, also for the visibility. And we also have the pipelines for a lot of the activity that we need to conduct soon. So this is really the International Year of the Quantum Science, validate the necessity for us to move forward and also build the good foundation for us to move forward. So naturally, you see the UNESCO, like Lydia mentioned, we want to provide you see the platform that we can build a world where the quantum technology are developed you see the responsibly and shared equally and contributed to sustainable development and benefit all. So the mission of the Global Quantum Initiative is really to mobilize all the member states and the partners through consultation, collaboration, and the pilot project to create a global quantum agenda that is inclusive, practical, and forward-looking. So I will just go very quickly about what do I mean about that one. So we talk about a lot about education, so capacity building. So through this one of the objectives is really to promote education, to promote the investment from government, and to promote the collaboration in the research capacity building at the level of the national level, and also the collaboration, and by developing some of the education materials and platform that we can share globally. The second one is the infrastructure. So we'll advocate for the global the government for the investment at the national level, but of course we'll promote some other mechanism like Lydia mentioned, remote access and share the facility, and so to enable everywhere they can access, they can share the infrastructure. The next one is awareness, is the quantum literacy, and we hope we'll have a global campaign to raise quantum literacy, and we hope all the scientists in the quantum, you can get engaged for the local engagement of the general public. And the next one is really collaboration, cooperation for the science community and for the industry, private sector, inventors, and society, as we just heard about using the quantum economies. And the last one is we want to, through this process, to have the responsible and ethical quantum innovation and to build using the governance for the future. That's, we heard also a lot about this one. So we hope you see through this process and we can bridge the quantum divide, and through the actions that we have usually been done and we promote to do more, and advancing the anticipatory governance and foster responsible of the innovation. So the guiding principle for us to develop this initiative is really using the inclusivity. And we will use it to make it inclusive, and we will heard all the diverse of the voice. And we will be responsibility, and we will use integrated ethical and social considerations for the innovation process. And we make it sustainable. It's not used for the short-term visibility, and it's not used just to create more dependence, but we want to make it sustainable. And we will promote the cooperation. The quantum, the challenge right now we're facing, we need to use the global collaboration with that one. The process should be very transparent, and during the process for the decision making, for the resource allocation, for the evaluation, and everything will be transparent. And we will also make it adaptable, because you see the science itself, technology itself is evolving every day, and we need to make itself also adaptable to the change the situation and to based on the lesson we learned, on the feedback we received. So the design, the principle is we will have the phased stage for this 3 years program. So the fourth year of this year, and we will try to have the consultation, to have the governance set up. And we will conduct the regional consultation with the different partners, and to see what really the governance means, and what the fundamental, the challenge for the different regions, and which kind of the key aspect that we should build in the governance for the next 2-3 years. And we will have the pilot project launching, like you see the remote access in the Latin America, like in the education program in Africa. All these kind of the things, we will launch it based on what we have built on. In the 2027, we will scale up all the pilot project, and we will try to have the first draft based on the consultation we conducted this year for the zero draft of agenda itself. Then we will go through all the wider review and get engaged all the communities, all the countries to provide the insight, their feedback about the agenda. And then we also would like to explore all the different prototype mechanism, how we can work together. For example, we want to develop something like the global quantum observatories. So we will monitor the progress made, capacity building, and the gap that it is, already we addressed, or you see the new challenge we are facing. So we will provide you with regular monitoring, we will tracking the progress, we will inform all the partners. We also try to build the regional quantum hub who can be the focal point to provide you with the service at the regional level for the global quantum initiative. So in the 2028, we hope we will refining of the draft of the agenda so we can prepare for the launching of the 2030 after some years more preparation. We also do the review and about you see what happening, and so we can also include that one in the refined agenda for the future. So we plan to get that launch in the 2030. So between you see 2029 and 2030, and we will engage all the member states and all the stakeholders and to see you see their engagement, to see their feedback, so we get all the preparation work done. So the key deliverables, and we will categorize you see the three, category, and one is the knowledge products. Basically to share you see all the understanding and to share to make you see that we reach some consensus on the way you see that we build the agenda for the next many years. And we also have the pilot, like you see the capacity building, education, and also prototype mechanism, and also you see some other consultations, the process. And the last one is we will try to have the coalition building up. So build you see basically the partnership, and also you see through the science diplomacy and to build the trust among all the stakeholders, and then prepare for the launch of the agenda in the 2030. So we have, you see that right now, in our designing, we propose we have the three partnership modality. One is the funding partner, who will, you see, take the, in the steering committee, and will lead at least one priority area, and also strategically for the investment and the senior liaison support. Then you see we will have more program partners who will designing all the different project activities and also provide guidance and expertise, and also mobilize resource for our joint effort. But I expected we will have more contributors who will provide more concrete activities, contributions, like to organize even one training workshop, like to provide the one toolkit, or this kind of the things. So we are quite flexible, and we can also add more the type of the partnership modalities. So as we're launching of the initiatives, we have a lot of immediate actions we need to take, like whether we can confirm our governance arrangement and also technical advice support, and how we can secure the initial funding, which is very important. We also propose that we need something 3 million for the next 3 years. And we also will soon launch the regional consultation process, as I mentioned, and we will also launch the first pilot project and the communication channels and to outreach what we agree today. So we have a lot of to do, and we really expect your engagement, your support, and also your feedback. I think finally, I would like to say, and this initiative will be part of our international decade for the sustainable development, which Jonathan also mentioned earlier. And we hope also you can get engaged of the international decade for the sustainable development, that we make a call for 3 times, and we will continue to do that. Thank you. Thank you for your attention.
Thank you very much, Xiaofeng, for introducing the initiative, the Global Quantum Initiative, that UNESCO has initiated as a result of the International Year of Quantum Science and Technology, and due to what we have seen, the need to continue. I think yesterday and today we heard enough of why and how we can continue the momentum of the year. So I don't need to repeat again why, like the quantum divide, the need for education, for curricula, for all this. So we really need something to continue, and this was the main motivation for us to start this initiative. And all the details of the initiative, as Xiaofeng presented, you will find it in this QR code. If you scan this QR code, there is a web page dedicated to the initiative with all the details, how you can contribute, how you can become a partner. And before I go into the discussion of this panel, I would like to acknowledge all our partners, founding partners who worked with us really to initiate this. You see all the logos here on the screen. United Nations University, GISDA, of course, Geneva Science and Diplomacy Anticipator, Open Quantum Institute, African Academy of Sciences, ID Quantique in Canada. I hope I did not miss anyone. So basically, IUPAB, I'm so sorry, International Year of Pure and Applied Physics, of course, I cannot forget this. So really all these partners worked with us, and I'm really happy with that and really grateful. So this panel is mainly to discuss how we can do that and why actually we need to do that. Because all the details, I'm not gonna speak about the details of the implementation, but really why and how, because this is what will guide us on how to continue. And yesterday, during one of the intervention, I liked very much the quote, is that now we need to stop observing and take the control. Now we need to know how to control the quantum technology worldwide and not just to be observers. And I think this initiative during the next 3 years will help us to take this control over as a community of scientists, of course. So I would like to start the discussion today. And one more thing, sorry, I want to say is that this discussion is not only for the founding members of the initiative, but it's actually for everyone. And that's why, besides the esteemed panelists who are members of the initiative, we also have a representative of one member state who's taking serious steps in developing a new strategy for quantum science and technology. And we need to see how this initiative can actually help member states to continue doing this. So I would like to start with Mira, who unfortunately couldn't be with us today for last minute reasons. So she is online from Geneva, from GISDA, Geneva Science and Diplomacy Anticipator. And Mira, I would like to ask you, can you hear me well?
Yes.
Okay, perfect. So from a science anticipation and the diplomacy perspective, what risk do you think is the most that we want to prevent if inclusive cooperation is not institutionalized early enough?
Yes. Yeah, thank you very much, Amal, for the question. And before I come to the answer, first of all, also good morning from me. And thank you very much also, Xiaofeng, for your great remarks and for, I guess, officially launching the Global Quantum Initiative. I first really want to say that we at GESTA, but also representing the Open Quantum Institute, are really honored to be partnering with UNESCO, with UNU, the African Academy of Sciences, IUPAB, Institut Quantique, and others on this initiative. And I really hope that those of you who are hearing about this for the first time, you will join us, since I think it really is the way to continue using the energy that we've built up through the past year, that we've heard, that we reflected on over the past 1.5 days, to use it and continue, because otherwise all this energy would, I mean, we're physicists, so we know that energy doesn't vanish, but we need to channel it somewhere, and I think the GQI is really the way that we can channel this initiative. And so I think if we didn't do something institutionalized, we would go back to what we're very good at, unfortunately, in the world, is to our own silos. And I think really with quantum technologies, and we've all heard the global cooperation, the scientific cooperation, is the opportunity to not have the silos, but to work together and to, yes, we have challenges, but overcome these challenges together and find novel ways of governing technologies responsibly, developing them responsibly. And so the biggest risk, and I'm really sorry, I'm not new. I know Tommaso had said it in the panel before, but it is the quantum divide. And I think if we don't institutionalize something now, we will end up in a situation where just a few handful of nations hold the keys to the quantum era. And this is really what we should avoid. And so I think and kind of in particularly avoiding this dual layered exclusion. On the one hand, the economic exclusion and the epistemic exclusion, so just knowing about quantum technologies and the potential benefit of quantum technologies, but also knowing how we can use them for societal good, and kind of really providing the solutions. Since I think that the areas where quantum technologies will potentially have the biggest benefit are those areas that are currently what we say are quantum underserved. And that's a situation we're already seeing, and you've showed that in the survey, and that we really urgently need to address, and that translates into the second biggest risk, which is of course the security risk. Through that, even if we have some few nations who are aware and to go to, in the case of quantum, post-quantum security, if we don't do that as a globally for all of us, we really have asymmetric risks and that asymmetric vulnerabilities, and there will be some regions that are extremely exposed, more exposed than others who've kind of skilled up early and who implemented post-quantum security. So I really think that we need to use, as you're saying, anticipatory governance, anticipatory diplomacy to prevent this type of quantum divide. And to prevent, we use with the quantum security, we use the harvest now phrase. And so to kind of change that a little bit, we must avoid a situation where we harvest now and govern later mistake. I think we've made that mistake with, for instance, AI, and we really need to act now in order to avoid that mistake, and must ensure that this window remains open for all, for collective steering, before the technology reaches a level of maturity that makes global alignment even more challenging. So I think these are, to me, on the one hand, key risk, but at the same time, by it being risks, also the key reasons why we need something like the GQI now.
Thank you very much, Mira. And the quantum divide, again and again, one of the biggest risks that can lead to lots of consequences economically and on security and others. And we have seen actually the divide in other technologies before, and it was not really the best thing to do, because many nations missed a lot. But also it's not only about what the nations are missing, it's also about those who control the technology are also missing, because they don't have enough talents if they don't share the knowledge and the experience. So this takes me now to United Nations University. What do you think from your, as working in one of the institutions that helps a lot in developing policies, what do member states most need on the policy and the governance side right now? Is it the evidence? Is it the tools? Is it the policy learning space? And why? And if you can identify one of those, how can an intergovernmental institution like UNU do to solve this? Thank you.
Thank you very much. As you know, most of member states lack the fundamental policy infrastructure for quantum readiness. And this can be translated into three different policy categories. One is the evidence-based policy brief, where it can translate this quantum technological complexity into government implication. And this is very important for leaders to be able to understand the direction of travel, and also in terms of vision sets, and also be able to fathom the knowledge gap that is needed to be able to arrive at such vision. Yeah. And second is also comparative policy framework, where different countries, you can show different countries how they are approaching this quantum strategy. And it is very important as countries begin to warm up to this technology, there's a need for them to have a national determined strategic policy developed in order for them to be able to assess and the threats and also the opportunities that it brings. Thirdly is a structured policy structured policy brief where different countries can exchange experiences without having to invent the wheel. And this convening space is very important so that we have this global platform where countries can talk freely and then exchange ideas and then build on their capacity. And why this is important is, but as you talked earlier on, the quantum technology is a technological gap, but it's also a governance gap as well. And then United Nations can help this member state, or can help this member state to be able to close this gap by helping them come together in a form of convening spaces to be able to talk freely, to be able to share ideas and also assist each other. And so this is basically what we can do as what the countries actually can marshal in terms of what they need right now, put everything in policy perspective, and then work on it towards their goals. Yeah.
Thank you very much. So national structured policies, I think this is the key message here that is really needed, and that's what we hope we can do, UNESCO, UNU, and all the other organizations. So now if I move to more focused on Africa, and if I talk to Professor David from the African Academy of Sciences, from the perspective of Pan-African Scientific Academy, where do you see the most critical bottleneck today for African participation in quantum sciences and quantum technology particularly, and how the global cooperation can actually help passing this bottleneck?
Okay, thank you very much. On behalf of the African Academy of Sciences, that's been a key partner on this roadmap. We want to reiterate our vision as to transform the lives through sciences, and then also linking this with our mission of leveraging our science, technology, and innovation for sustainable development. This ties in because the academy, as it is, has a tri-mandate as the only academy on the continent that has the AU recognition and then the backing of governments that have helped in its setup. And our goal is to help with excellence recognition of scholars and being an advisory and think tank on the continent, and then also help with the implementation of our STI policies. Now, coming from this vantage point as an organization that has the backing of the AU, this is really central to our initiative in terms of the quantum initiative that we have now. So what are some of the bottlenecks that we see? I want to highlight only 3 of these ones that I think that they are key, that we need to take them into consideration. I call it, from our perspective, what are the pathways, instead of looking at just the pipelines that we have always looked at it. So this one, we mean, how can we look at the talent levels that we have? We have the talent, but what is the sequence of the exposure that we give to our young talents that we have on the continent? We have brilliant talents on the continent that we need to grow in here. Continually, we've heard about the curriculum development that has to take place. Then from that, how do we link that with our funding of postgraduate students, for instance? Then there is also a continuous link with capacity building in terms of the early career, in terms of the postgraduate pipelines that we are going to help and have these ones institutionalized and stay on the continent to be able to grow them to a level where they can form their own groups and become research leaders, which is one of the key things that the academy is been championing on the continent. The second point I want to highlight is access, which throughout this conference, throughout this meeting, it's been highlighted, and even with the report, is access and infrastructure we see as a gap. We have limited CU times that is on the continent, and then access to some of the experimental laboratories which is actually creating some levels of isolated excellence. We can give typical examples that some member states are helping with Morocco, helping with the QHPCs that we are accessing, and then South Africa being one of the key players on a continent that is supporting with these. But these are isolated cases, so it's something we want to look at. The third point that I want to look at again that has been highlighted is in terms of the policy and coordination. As earlier mentioned, many of our systems on the continent that still lack funded national quantum strategies, which has to be tied in with the budgets and things like this. Then moving forward, and in terms of the cooperation, I still want to highlight 3 key points that we can also look at. Linking that with the access is to have some sort of an access charter, kind of access charter that we can all work with, where the partners, which is also linking up with a report to have an in-kind compute time. We can have the remote access laboratory times that through some bookable quotas and service level agreements that we can do, so that we can turn these goodwill into practicable research times. The third one, which is linking up with the capacity building, will be in terms of faculty and then our curriculum development. And this is really key. We need co-development. So it's not just developing by the units themselves. We need that co-development of open quantum curriculum. This is really key to me. And then faculty development that is embedded already within the AAS network. And this will help in accelerating teaching capacity. It's going to help us with supervision. That is also very key. We can also propose for about a 3 to 5 year early career post, sort of taking care of our postdocs. We already have some initiatives from the academy that is building research groups in terms of research leadership, and then the rising leaders that we want them to stay on the continent so that we can close this gap. Then thirdly is still on the policy sprint. So AS fellows and then the GQI can help with policymakers, the ministries, to co-develop their readiness notes and then the roadmap. So for me, the key point here will be access that you can have to schedule. We need a curriculum that we can adopt, and then also the policies that we can easily find on the continent. Thank you.
Thank you. Thank you very much. I think 2 important things here, that there are brilliant talents that we really need to strengthen their capacity further, and of course the policy coordination within the continent. This is actually very important. And now, since we are talking about policy coordination, I would like to go to Professor Ahmed El-Shibini from Egypt. And Egypt is one of the member states that has taken concrete steps to articulate a national strategy for quantum science and technology. So from your experience and also from your perspective, what were the most critical enablers in moving from interest to real implementation of a strategy? And also how can this initiative help member states to do that? Thank you.
Thank you. Thank you, Dr. Amal. Before I answer your questions, I would like to thank UNESCO and the government of Ghana for organizing such a beautiful event, very well organized, with warm hospitality, and so thank you very much. Bringing the quantum community together and bringing the, as we call it now, global south together, which is very important, very vital. What is happening in Egypt now, as far as quantum is concerned, is actually a testimony of the success of the International Quantum Year. Egypt, for years, have been active in the quantum science and technology domain as far as education and research is concerned. We have a good base of researchers and of educators, and many schools have curricula for postgraduate and some undergraduate in quantum. But we stopped at that stage, research and education. But with the quantum year, with the International Quantum Year, before that, Egypt was one of the 145 countries that didn't have a quantum strategy. But with the quantum year, the government realized the importance of coming up with a quantum strategy. Again, to move from just educational research into value add and quantum use in the development of the country in different fields. So we did two things. I will take you back 3 years. In 2022, 2023, the government created what is called the Supreme Council of Artificial Intelligence. It's a body that headed by the Prime Minister of the country with representatives of different ministries and different stakeholders responsible of setting strategy and monitoring the progress of AI in Egypt. And that council came up with a strategy in 2023, 2024 of AI in Egypt. 2 months ago, the Cabinet of Ministers renamed that council to be the Supreme Council of AI and Quantum Technology. Again, to create a body that has the mandate and responsibility of drafting and coming up with a strategy for Egypt in the domain of quantum technology and quantum computing specifically. And then the Ministry of Higher Education and the Academy of Scientific Research and the Ministry of Communication created working groups that are now currently working to draft a strategy for Egypt in quantum computing, focusing mainly on quantum computing, quantum cryptography, post-quantum cryptography, quantum communications, machine learning, and some useful applications for the government of Egypt. Our approach was to bring all the stakeholders together, academia, government agencies, companies, and startups to help in drafting this strategy. So it is inclusive, representative of all the ideas and the concepts in Egypt. And we do it in collaboration with international partners. So we get support from CERN in Switzerland, from UNESCO, and in that regard, I particularly thank Dr. Martin from CERN and Dr. Amal from UNESCO for their support. And our approach was to study the current situation of Egypt in quantum, assess the current situation, do a SWOT analysis to see the strengths, the weaknesses, the opportunities, the threats, and then to come up with the set of priorities for the government, short-term, medium-term, long-term, spanning 10 years, 3, 5, and 10 years. What are the priorities? What is needed for the development of the country? How could we transform quantum from science and research into applications and services that help development in specific areas? Security is definitely one of them for critical infrastructures and communication and agriculture and some other fields we are identifying. Hopefully by end of April, May, we will be launching this strategy for quantum in Egypt. And actually, this would have not been possible without the momentum that came out of the International Year of Quantum. But if I may share, I would like to share with you some thoughts that came to mind listening to the very fruitful debates and discussions we have been having since yesterday and today. Actually, it brought me back 20, 25 years. The same issues have been discussed and debated. It is like a déjà vu. Quantum divide. Remember the term digital divide 25 years ago? Quantum literacy, digital literacy, quantum economy, digital economy. So we have been through this with different technological advances. So 25 years ago, we're talking about the digital divide between the North and the South. We are talking about the same thing in quantum now. We emphasize the importance of international regional collaboration. We are emphasizing the same concept now. We emphasize the importance of education and research. We are emphasizing the same thing now. So it is actually, it's a cycle that every technological advancement go through. So we are discussing pretty much the same issues and the same problems that we have been facing. Haven't we learned from the past how to deal with these issues? Setting policies, having ethical guidelines, having harmonized strategies. We have been discussing that for the past 30 years for different technological developments. So I think we have a base to build on to try to mitigate and overcome some of the issues that we are discussing now and wrestling with. And actually, UNESCO have been very instrumental in addressing some of these issues when it came to the age of digital era, AI. Actually, UNESCO was actually the beginner to come up with an AI ethical guideline, the white paper. So we have precedences, we have a base to build on to try to mitigate most of the issues that are facing the development of quantum. It happened with digital. I'm coming from a communication information technology background. I'm not a quantum guy, but I am a professor of telecommunication information technology. So I have seen this in that domain of communication information technology before, and I've seen it in the AI era 10, 12 years back. So it's now with quantum. So it is happening with every technological advancement that is coming close to being mature and to serve the society, not just the research and academic community. So I believe that we have a base, we have learned it from past experiences, we have the agencies that can support in doing that, especially in the South, but also between South and North. So I think we are in a good situation. I know the socioeconomic, geopolitical situation is a bit more tense now than it was before. But again, I believe we have the instrument, we have the brains, we have the institutions that will help us to overcome and mitigate most of the issues that we are wrestling with.
Thank you. Thank you very much, Professor Sherbini, for sharing the model in Egypt and also for recognizing some of UNESCO's work. And UNESCO indeed has the recommendations on the ethics of AI and also recommendations now in neurotechnology. So the governance and the ethical aspect of the technology must be taken carefully in consideration. And I just received a notification from the colleague here that we need to wrap up quickly. So I need only a couple of minutes. For each of you, please, the same question, but please in 30 seconds, if I can have an answer. Looking ahead from now, what do you think a concrete action or a form of collaboration that we can take right now, either through this initiative or through your own institutions? In 30 seconds, please, each. Can I start with you, Professor? Yes, please.
Yeah.
Yes.
Actually, I will take an initiative that was actually announced yesterday, which is the Alliance, the Quantum Alliance, African Quantum Alliance. It was announced yesterday by many academic institutions in the Global South, as we call it, mostly African, and again with the support of some academic institutions from the North. So that, to me, was a very brilliant idea, came in time, and announced it on an African soil with the support of international entities. So this is a good initiative that we could build on.
Thank you. David, please.
Yeah, so from the academic perspective, we think that we can help with the member countries to polish on their quantum readiness, which is very important. This is a key thing that we want to work with UNESCO and then the QGI to come up with a roundtable for these conversations to action these initiatives. And AAS is ready to give that support.
Thank you. Yes, please. Kenneth, please.
Yeah. So coming from UNU University, I think by convening policy dialogue to bring all these member states experts and scientists and industrial leaders to discuss quantum-specific governance challenges, focusing on emerging priorities, policy gap, and also international cooperation that fits into the International Quantum Initiative should be
Policy
looked
dialogue,
at.
thank you. Mira, please.
Yes, so to everyone who's working on quantum, I encourage you to look at the Open Quantum Institute's framework for how to develop use cases for the SDGs. We have a long white paper around this, so there's no excuse to say you wouldn't know how to gear use cases towards the SDGs. So that's the really concrete action to take. And the second one, to all the policymakers and colleagues in the policy and diplomatic sphere, we have a conference on May 6th that is part of the GQI on quantum diplomacy in action. And that is really, I heard the colleagues from the UNU and also from Egypt speak about how we learn from each other and national quantum strategies and have this comparative exchange. And that is a very concrete step to be there and to have these discussions there. So again, no excuses, very concrete. And I hope a lot of us see each other in one or the other venue.
Thank you very much, Mira. So Mira, I think, got the best way to conclude. No excuses. So there is no excuse indeed, because now I think we have a lot of platforms available that we can work together and start. And this initiative, I hope it will be really a platform that can connect all of us together to work towards closing, hopefully not only reducing, but closing the quantum divide. Please join me again, thanking the esteemed panelists. Thank you very much. And thank you all for listening, and we move now to the next panel. Thank you.
A wasted chance that I feel given, so I'm never gonna dance again the way I dance with you.
Virtual DJ.
Dance forever, and now who's gonna dance with me? Please stay.
Ladies and gentlemen, as we get ourselves ready for the last but one panel discussion for this conference, I'd like you to take note of the following announcements. All participants who would want to participate in the cultural visit after all is wrapped up at the Christian Ball Castle here in Accra are urged to speak to the information desk and leave their details. And do remember that there will be a bus at the front of the hotel to convey us for that cultural visit. Secondly, as well, we'd like to encourage all of you as much as possible to have a look at the screen behind the hall. And this has all of the entries and winning entries for the IUPAP IYQ photo contest. And that screen is right there at the back, just before the the National Ambulance Team. Distinguished ladies and gentlemen, it's now time for us to zoom in on our next panel discussion. This will be on the topic, Quantum Science for Global Development, Building Talent, Expanding Access, and Shaping the Future of National Competitiveness. Our moderator for today is a professor of quantum physics at the Chile University in Santiago and is an associate researcher at the Millennium Institute for Research in Optics. Now, she inaugurated Chile's very first squeezed light laboratory and the first quantum optics lab in the country, directed by a woman dedicated to generating intense quantum light and advancing second-generation quantum technologies. Distinguished ladies and gentlemen, it's my pleasure to bring up here on the stage Carla Herman. Please welcome her with a big round of applause.
To support Carla in discussing the topic is Rosario Fazio, the head of the Condensed Matter and Statistical Physics section at the Abdul Salam International Center for Theoretical Physics. His research focuses on quantum transport, superconductivity, and quantum information in many body systems. Rosario, thank you. The next panelist is Prince Osei, the president of the African Institute for Mathematical Sciences, Ghana, and the lead of the Quantum Leap Africa initiative. He is a mathematician whose work focuses on quantum gravity and its application. Prince. Our third panelist is Daniel Diharo Moraes, head of Emerging Technologies Ventures. He leads strategic initiatives in quantum computing, blockchain, and cybersecurity, bridging the gap between academic research and industrial application. With over 15 years of experience in distributed systems, he has co-authored influential research on post-quantum cryptography for central bank digital currencies and AI-driven industrial optimization. Thank you, Daniel. And the last but not the least is David Makwende, Quick Network Manager, European Quantum Industry Consortium. He coordinates strategic initiatives across expert groups to advance the European quantum ecosystem and foster collaboration between industry and research. A Qiskit advocate and contributor to the open source community, he has co-authored quantum computing tutorials and developed cross-platform integration tools. David, you're welcome.
Thank you very much. And so, ladies and gentlemen, Carla Herman of the University of Chile, our moderator, our panelists, Rosario Fabrizio, Prince Osei, Daniel Morales, and David Bokwende. And of course, we look forward to a more brief conversation so that we can make the time. We're very grateful to you. Over to you. Thank you.
Hola, hola. Okay, well, thank you very much for the organization to have this panel and also to invite me to moderate it. I'm glad to be here, to be honest. So welcome to this panel. This panel will be about quantum science for global development, building talent, expanding access, and shaping the future of national competitiveness. I think that we have discussed several things like yesterday and today morning in the different panels, and I would like to briefly try to highlight some points that I think are very important, especially for this panel that we will discuss, like how to come from these documents or strategies or things that we would like to happen to the real world where we are working and trying to really make a change where we are. So yesterday, across several panels, we have heard about the quantum divide, that of course we want to close it, and we acknowledge that there is a risk for that the emergency of quantum technology, if we are not careful enough, this will not close the gap, but increasing some gaps, so we need to pay attention on that. And for that, I want to highlight that I understand what, as the community of scientists, we would like. So we want to close the quantum divide, and we don't want to increase more gaps in general in science. But I think that we have to pay attention that this is us, and not necessarily the politicians that will run and that will decide some things about how this goes. And so I think that we need to pay attention on that, and that we need a seat on the table of the politician decisions. And sometimes the community, the scientific community, go in the other direction. We believe, I will not say they, we believe that we are supposed just to do science, but science is pretty much related to politics. And I think that we need also to embrace and to generate the opportunity to have a seat on the table where these things will be discussed by politicians. I think that this is important and has somehow arisen during the conversation. Also, we have here yesterday, we will go to this point particularly, but that the Global South does not need help in the charity sense. We need partnership, we need collaboration, we need people from the Global North to acknowledge our value and the talent that we have, but not in the sense of charity. It's not what we are asking. We are asking to have a seat on the table and to discuss these things with the Global North, which is very different than just help, okay? And so we also were reminded at some point that the quantum revolution is not just only a scientific revolution, it is also a social, ethical, legislative, and political revolution. So actually, we were in November in Istanbul discussing this ELSA aspect of quantum technology with some of the people that are here. So it's important for me not to lose that focus either in the discussion that we have. And so I think that the mission of this panel is how to discuss how can we move from these good intentions that we all have and we have discussed to the real system that are preparing the people, the institutions, and how the countries can really participate and have a seat in this global discussion. So I have tried to divide the panel in 3 parts. Let's see how that goes. And the first one is about the quantum readiness, really. One thing that became very clear yesterday that talent is everywhere, but opportunities are not everywhere. And I think that we have to address that point, and I would like to unpack what really means when we talk about the quantum readiness, because it's not just about training individuals, it's also about building these systems and infrastructure and research. So for that, I will start with Professor Rosario. From the perspective of the ECTP and long-term scientific capability building, which of course you have plenty of experience, what does the system-level quantum capability actually requires beyond training people? What are the elements that are most often missing in that sense?
So thank you very much. And
So, as you very nicely expressed, many things have been said during these 2 days, so I will try to not to repeat things. And to do so, I will start with how, just very brief description of how ICDP operates, which might be a good way to explain how ICDP tries to implement and to address these issues that you mentioned. So the driving principle of ICDP are excellence, inclusion, international cooperation. And this is done through the implementation of many different programs. So one aspect which we think is very important is that, say, training and should be done at various levels and should touch all the career stage of individuals. And of course, it should be tailored depending if we are talking undergraduate or giving opportunities to people at PhD level, postdoctoral, or advanced career. And the different programs that apply also to quantum technology programs are designed at ICDP at all these levels. Of course, I mean, this is not enough. As you correctly pointed out, if these programs are not accompanied by the possibility of just building up more long-term collaborations that go through institutional agreement, of course, their impact will be limited. Something which ICDP is trying to do, and it's in the strategic plan for the forthcoming years, is kind of science alliance, in which, I mean, these programs are associated with institutional agreement of cooperation with different partners at national level all over the world. And this is important. Something which I think it is important, or at least I think is important to stress, is that in the specific areas of quantum technologies, I mean, there is a kind of evolution in the way we are thinking people should be trained, because, you know, up to some years ago, people that got interested in quantum technologies came from very different backgrounds. Physicists, mathematicians, and physicists came from different areas, condensed matter, optics, or whatever. And now we are building up a scheme to really train quantum technicians, quantum scientists, and of course, this is accompanied by an evolution also in the way programs should be tailored to fill this needs. And so I guess, I mean, my feeling is that we are really in an evolving stage of the way, for instance, we train people.
Just to go in that point a little further, what will be your advice for the global south that are trying to build this network of research to try to focus on the long-term activities? Because you have a lot of experience in the ECTP regarding that. I guess that we can learn from your experience into how to build this long-term cooperation to highlight and to have more potential to the research that we are doing, for example, in Latam and also in Africa.
So I think, so if I may say, I mean, many of the things, I mean, it's not difficult to imagine what should be done. I mean, the difficult thing is to do it. I mean, as we heard, many nations are designing quantum strategies at the national levels, and I see that at different levels, people, I mean, despite certain problems that we were discussed before related to political situations, I mean, there is the will to create cooperation among different nations, also especially because, I mean, it is probably difficult just to operate at individual level. So cooperation is really important also, if you let me say this from an opportunistic point of view. I mean, it's very hard to do it alone. And I think that the way we scientists collaborate and cooperate is known, and I think it can be applied also to quantum technologies. I think it would be very interesting to think to build up large-scale facilities. I mean, this morning it was mentioned CERN, Sesame. Thinking to something of this kind for quantum technologies might be an interesting avenue to explore.
Thank you so much, Professor Rosario. Prince, from your experience at the AMS and Quantum Leap Africa, if talent is everywhere, as we have here and discussed, what are the main structural barriers that prevent that talent from becoming real capability in the global south?
Okay, okay, thank you very much. I think you already said it, and it's been highlighted here over and again since yesterday, that talent is everywhere, but opportunity is not. So, number one, if you have, for example, in Africa, very young, bright talents, and they are interested in doing quantum computing or quantum communication, within their university, they do not find real expertise. So one of the major challenges is finding real expertise in the various fields who can train and mentor the students. And this is very tough. So what we have done at AIMS to address this is that we bring the students from all over Africa and then bring the lecturers from different parts of the world. So where we do not have the faculty and the expertise, we bring them to meet the students. So you have a student who is very talented, coming from a refugee camp in Sudan, coming to AIMS, interested in doing quantum computing. And then we have real experts coming from somewhere in Geneva or in Canada who come to work with the students. And then in a few years, you see that this student is really at the forefront, developed and contributing clearly to the developments in the field. So it is a real thing that the lack of real experts is a real challenge. And that is one model that I have proposed that we use as AIMS to address it. And bringing real experts in the field to work with the talent pool is really very important. Now, the second thing is also that the training should cover both the fundamental and the discovery. So learning towards the fundamental and the discovery, as well as learning on project-based and use cases. So quantum technologies is still very early, and there are a lot of new ideas that are needed to advance the field, and diversities in thinking about the very foundations is very necessary. And so exposing the students to both the fundamental ideas and encouraging them to make discoveries is very important, as well as exposing them to project-based or use cases is also very good. And the last point I will make is the barrier of access. We've heard a lot about access, but the real thing is that, so I run a quantum hackathon. I bring 50 students from different parts of Africa, and I want them to run a quantum algorithm on a quantum computer. And I don't have it. I try to get, and I get a quotation from a UK company that is telling me that, okay, I need to pay $1,000 per hour for each of my students to run the code. So for my students to be able to run the code for an hour, I need to spend $50,000. And this is on a quantum computer that is not really, it's not really there. And there are other countries that are implementing export controls that we've heard a lot about remote access, which is great. But the point I want to make is that a few years down the line, after we have run our algorithms on the computers and they have improved, we may get shut down. In some countries, you cannot even sell a quantum computer that is more than 16 qubits. Okay, and that's why some of us have been advocating for flagship programs within the global south, where, for example, in Africa, we have a quantum hardware infrastructure that different countries contribute to the development. And when students are involved in the engineering and the learning, that's when they learn. When they are able to learn more, when they are involved and participate in the building of the infrastructure. So I think these are the three main things that I will highlight. Thank you.
Yeah, thank you so much, Prince, for this input. I think that we are all agreeing what you have just said. And it's also like, the first point at least is very similar to what Silvina was telling us today morning, right, about this mobility, because we need sometimes when we organize schools and conference, people from the global north to come here and to teach our students like the infrastructure that they have or the research that they do. And I think that this is an important point. And I think that I think it's also important to think and to address. I know that some scientists from the global north sometimes decide, for example, not to take overseas flights because they want to take care of the planet. And I totally understand that. But from a researcher from the global south, I'm asking you not to sacrifice our students, because nowadays we do have a good critical mass, and we want to teach them, and we need to have your expertise and to come here in person, because it's important for the students to add value and to the talent that we have. So I think that this is a point that is important too, and is one of the first point that you have discussed somehow when you invite people here. And to acknowledge the reality of the global south. So this is just an open question to the panel, whoever wants to answer very quickly, and then we move to the second part. But what do you think breaks most often, training, access, continuity, or pathways in this scientific community research? Anyone? Go ahead.
Okay, maybe I think pathways. So being able to, once the training is done, for example, a student comes to do a master's program in quantum computing. The student is a bright student from Madagascar, okay? And what next? The ecosystem in Madagascar in the quantum space is very limited. And so connecting the students to the next level in terms of creating internship opportunities in very good quantum computing labs and getting the students mentorship for the next levels of their careers are also very important. And also exposing them to the fact that they can translate the ideas they have and create companies out of it. Again, these fields is very, very early and open. There are a lot of companies that have started from PhD projects in these fields. So these are some of the gaps for me, the pathways, and after the training, creating the opportunities and creating the ecosystem within the region where the students can function.
Okay, thank you so much.
Yeah. Also, adding on to that, I think continuity is very important because yes, you can have training. Yes, you can have ephemeral access to whatever device is out there, but after that, what? Not only in your own country, in your ecosystem, like you maybe have faced a wall that you can no longer trespass. And I think that's a really important thing because we can have all of the resources of the world, but if they actually cannot access either opportunities, either more devices or more actions, all of the efforts that we have done will not be of any value.
Thank you. Daniel, do you want to add something?
Yes. The interesting thing is I noted the continuity and pathways. So continuity, when we are talking about quantum or the whole technology, we need to think from here to the future and not only from here to 1 year or 2 years, right? And that is very important for programs that will support this kind of technologies or innovation. And for pathways, when we are inside a country or inside an initiative, it's important to have these pathways not crossing each other. Otherwise, we will start to divide the investment on that technology. But throughout the country or through the initiatives, it's important to have these crossroads because in these crossroads, we can collaborate with the other initiatives and we can sum the support for these technologies. So that is my 50 cents for this point.
Thank you, Daniel. So for moving forward in the panel, yesterday during the panel where Claudia Fratiola was, she was the one that has pointed out that the Global South does not need help. We need collaboration, not competition. Collaboration is not optional. Someone said it yesterday also. So we need to build this partnership, and we need to be co-creators of this new technology and to have a seat at the table where decisions are going to be made. So part of this conversation, as I said, is not just technological. It's about power, participation, political, and having a voice in this decision-making. So for Daniel, in your experience with industry and extraction risk, and from the innovation perspective, what needs to happen so that quantum innovation creates local value instead of being extracted or outsourced?
Okay, and the easy and fast answer is create jobs. Just that. Okay, finish, next one. No. The problem is how to create these jobs in the Global South, right? And I take note of some things here. We need to create interesting jobs. That's a bit different. It's not the job that the people that has knowledge in quantum technology just goes and start to produce something. This job must make sense, so it must be associated with a national vocation, like in Brazil, like agriculture. A lot of people told about that here. And about the financial system, we have a very huge financial system there. So each country must understand its vocation and create jobs on it, right? And good salary and the academia integration, because the people that will work with this kind of technology, they came from academia, and they are very, how can I say, related with doing science and not just doing work to get money. They want to make the change in the company or in the world, right? And why to create jobs? Because we are discussing a lot here about creating capacity. But, okay, you created the capacity, but where they will work, right? And we are telling, oh, the brain evasion to global north. But if you don't have the job for these people in the global south, they will move to the global north naturally, you know. And going further, to create these jobs, it's important to keep the environment working. And what is the environment? The environment is constructed by three bodies, I can say. It is the academia, the government, and the industry. And all of those three bodies must conversate each other, right? And in Brazil, we have another body that makes the middle field that's called the Research and Development Institutes. I think all the countries in the world have these institutions. And these institutions are responsible to create the connection between these three bodies, okay? And to make it work, it's important to make these bodies conversate and to speak with each other. But we needed to create a framework to control, not to control them, but to keep track of what is being developed in this environment. Because when we start to make this environment work, it generates a lot of conversation between all of the entities. There is a lot of money running into this environment. So we need to keep track of this money and how much was invested, how much was get from profit, and how much social benefit it created, how many relations it created inside the country and outside of the country, you know? Because we are telling a lot here about international collaboration, and it is very important to keep track of this, right? And another point is the government investment in this environment, because we are working on TRL from 3 to 6, and it is exactly the death valley of a technology. We need to invest a lot of money for it, and we don't know if it will bring a profit or not. So we need some kind of support to keep the technology evolving, right? And the government has this kind of support, and it is very important. But one thing we have to note is to put this money inside the right companies, because we are telling about not divide the science or keep the science open, but quantum is in the right phase to decide that, because the big companies are looking for AI yet. They are not looking so much to quantum. And when they start to looking a lot to quantum, they will try to divide and close this science, because they need the profit and they will invest a lot of money and they will not give it to the community, you know? So, but small companies are different, and we probably have a lot of them in any country. Like in Brazil, we have companies that do optical communications. We do work with, I don't remember the word in English, but to do vacuum chambers. And we are trying to motivate these companies to go to develop quantum computing or quantum communication devices. And it is very interesting because all of them are open to it. And they are generating the future jobs for these people that we are capacitating now. So that's the point, to create the environment and invest in the national industry and the international collaboration. You know?
No, absolutely, and I just wanted to add that somehow we need to know our reality too. So we cannot just copy what the global north has already done, because our initial condition, so to say, is different. So the dynamics of the problem and the evolution of the problem is also different. So it's good to learn from the people that is going like ahead of us, but it's also very important to know our reality. What are our priorities? What is like our infrastructure, if there is, what is like the jobs that you have said, the jobs that we have to offer to these people that we are training? Because in Chile, we have the same problem. There is not a space for the people that we are training. Exactly. We know that they will move because we don't have the space, And this is a huge problem that we need to discuss later. Just go ahead, Professor Rosario.
So no, just to add, so I completely agree, and my feeling that in several different cases it might be very important to go beyond just national strategies. I mean, because probably nations themselves do not have the strength to create this environment. I mean,
Yes, and I would congratulate everybody here and the event organizers, because the event is brilliant. And I was talking with a lot of people here that is promoting these strategies in their country, and I see exactly that. Each country has a strategy, and they are, how can I say, developed for their reality. And it is very interesting because we don't have a silver bullet for this kind of strategy. We have to adapt it.
Absolutely. And I think that we also need to communicate between the countries in the global south. I think that it's impossible just for Chile or just for Brazil or just for any country in Africa to build this by alone. This is impossible. We need not just collaboration with the global north, but also between us. And sometimes this is hard also in Latam because everyone wants to shine. There is an ego problem here also, no? But we need to address this and to work together, really. So, David, from the ecosystem and the policy side that we know that you have some experience, how do we avoid reproducing global power asymmetries through standards, platforms, and supply chains? For example, in Latam, we don't have supply chains. Like the two enterprises that you have mentioned, we also have in Chile two startups in quantum, related to quantum, but we don't have anyone building lasers or EOMs or AOMs, or everything has to be bought from outside, from the global north. And every time that a system fails, it's a nightmare. It's a real nightmare to send the laser back because not all the company allowed us to open the laser and to fix it by ourselves. So we have some problems also in the supply chain. So David, what you can say about this?
Yeah, so I will answer from the last question to the first one, and also really tight about the ecosystem and the job creation. Let's be smart. If we are already doing something in any industry, in any vertical, or any technology, and quantum can be applied, tied, or used, let's be smart. Let's start from that. And for example, in Brazil, the banking sector is really good, and they have applied this. In the Northern Europe, it's really cold, and they know how to deal with this kind of cold temperatures, and they have cryostat and cryocoolers. So first of all, let's start by that. Then about the supply chain, I think it's a world problem. It's not only about the global south, the global north. It's a problem in every single region, and not only about quantum. In every single technology, the supply chain is one of the most critical parts. And I think it will come with the development. If we are training people right now in several technologies, at some point the development will come. The startups that you were talking about, if we are training people, we should also train about how to make companies and how to deal with international relations. So that's one side of the question. The other one about the standards, the global ecosystem in general. So yes, it is happening right now. It's happening sooner or earlier than other technologies. So right now we are starting with the quantum standards, even though we don't really have these complex systems. I think it's good, it's my personal opinion. The only problem is that not everyone is represented there in the different international bodies. And I think that's a problem, because if you are not there right now, you will be a follower, and you don't want to be there. You want to have your voice there in the table when the first draft bill. And that gives the conversation back about the education. We are training physicists, quantum engineers, but are we thinking about the legal aspects, the IP aspects, the legal representatives or the delegations for the countries? We have to start thinking about that in underrepresented regions. And get those people that has this kind of knowledge access to also these documents, these international bodies like ISO, AIC, ITU, all these things. Because as we were saying, the science is open, and maybe the ideas that one region has didn't came in the first mind of the people who is developing these standards for their own technology that you cannot open in Chile because they don't want to. So I think those are the steps about the training, having legal representation, also like building roadmaps and strategy. I know that there are a lot of roadmaps, a lot of strategies, but I think that your own country should have a paper that says, hey, that's the objectives we want to achieve, that's the things that we know how to do, those are the things that we don't know how to do, and have someone appointed as a representative to go to the international conference and say, hey, we think this, and we think that this standard or this different hardware that we are building has to have this kind of specifications.
So they just told me we are running out of time, but I want to still talk a bit more about the ELSA problems, that what you have just pointed out about this ethic, social, legal aspect of quantum technologies. We have discussed with Yasser in this Istanbul meeting that we have. Also, Claudia was there. And he pointed out yesterday this expression about how to avoid this technological colonialism. And I think he's right. I mean, I still think that maybe we, like us, the community, we don't want that, but the decisions will not be made by us. So we need to address this and to have a seat on the table of the political conversation. So regarding that we want to avoid this, keeping this quantum divide and the general gaps that we have in science, I wanted to finish the panel with this open question that anyone can answer, to jump to answer. Whose problems are we actually solving or trying to solve with quantum technologies? How do we prioritize our needs in the global south, because they also need a voice in that table? And who get to decide that?
Maybe I can start. So for the colonialism part, it's funny because, as you said, we don't have to help because, like, in a charity way, because it's good and it's look good. The help should be going together. So, and coming back to the strategies, you have to know what do you want to achieve and the problems that you want to solve, because they are your local problems. The second step is not having access to the devices because we don't have them yet. It's like, how can we build together these different solutions to our own problems and do that together? It's not only that I give you my data or you give me access to your computer and that's it. And next year, we don't know each other and the problem isn't solved, neither from your side, neither from our side. And the worst part is I have these people who have worked in this and cannot. So I think that those are the steps, the strategy, the collaboration, share IP, and building the community.
Yeah. I think you told who will decide that, right? I think we can help to decide that. We cannot decide by ourselves, but doing science diplomacy, it's a new term, right? And every teacher, every professor could ask for the politicians to do the rallies to enable the quantum technologies. And taking care of the vocation of the country or the region or the groups that are involved, right? Like, I am very happy to be here in Africa because we are brothers, right? And it's a pleasure to be connecting with you and discussing the problems that we have together or the solutions that we can have together. So this is diplomacy. I'll get all those information and get back to Brazil and try to create some kind of programs to enable more contact between us, you know? And even in South America, we need to do that, right? So through science diplomacy, I think we can change the world. I can change the things to what we want, right? So I think that's a good way to go.
Okay, I just want to highlight two things. First is governance, standardization, and responsible innovation. And we've started the conversation very early so that we do not make the mistakes that we have made with AI. So it's very important to have governance frameworks, not strict frameworks that stifle innovation, but something that encourages responsible innovation. And then on the other hand, there's also values, and the values of inclusion, and the values of accountability, and the values of doing quantum for the good of humanity, I think should dictate the way we use this powerful technology that is on the horizon. Thank you.
So I agree with what has been said. Something I would like to remark, and it's related to what I said before. I think I would go as soon as possible in the direction trying to have transnational quantum strategies. I think this would be a way to really force different nations to have a common goal.
Yes, I totally agree with your perspective, and I think that this is one of the maybe the goals from the next 10 years, 15 years of this global quantum strategy. So I think that we can conclude that somehow quantum technology might not be neutral, and we need to understand that in order to avoid that. They will either deepen existing inequalities or they can help to close them, but we need to address that this possibility exists. The worst thing that we could do is to think that this could not happen, but because then it happens. And I think that for sure, something that I also repeated yesterday, collaboration is not optional, and it's something that we have concluded just now. Inclusion is not a decoration, and it's not a favor to us. Inclusion is mandatory in this new technological, arising of this new technology, and capacity and like this collaboration and partnership is not charity, it's co-creation. We want to co-create this technology and to add value to this global development. So I think that with this we can thank all our panelists, and thank you for this very meaningful discussion.
We're very grateful to Carla Herman and all of the members of the panel. Thank you so much. Once again, we'll do a big round of applause for the appreciation. Thank you. A key conversation from here, which we'll definitely take away, will be ensuring that you, who are the core of the quantum technology community, have to have a seat at the table, have to have a say, which is recognized, especially when it comes to the formulation of international law with our various international organizations. Thank you all so much for being a part of this. What is left of the morning is a coffee break, after which we'll come in for the final moderated session for the afternoon. Before that, however, we'll view a trailer for a special feature on quantum science, and then we'll retire to the area right behind the hall. Will be directed by our ushers who are in black apparels to the area where we're going to have our coffee break. But just before we close it this mid-morning, let's have a look at this special feature.
Quantum mechanics and relativity are the place where physics becomes really surprising and conceptually revolutionary. There's a completely different way to do computation.
Quantum computing is the only thing that fundamentally changes the rules of computation.
And it was always supposed to be 5 years off or 10 years off. And I thought quantum computing might be like that. I don't now. It's clear that sooner rather than later we're going to have quantum computers. We have seen evolutions of technology, now we're about to see a revolution. But every new technology has consequences.
Scientists say it's the technology that could revolutionize computing.
U.S. companies are spending billions of dollars investing in Chinese companies involved in critical technologies like quantum computing.
There is absolutely a geopolitical arms race on between companies and nations. National governments, the number one reasons that they're behind this is national security. China, the numbers are off the charts on what they're investing in it.
There's a reason to fear getting behind in quantum, so you have to participate in a race. You don't have a choice.
How do we think about what's actually going on? What can I do when I have the quantum computers? How can I change the world by designing new chemicals, new materials? But you do have to be willing to take some chances and accept failure. It would be much easier to build a spaceship to fly to Mars. But building the quantum computer is more exciting.
Quantum is going to be the world that we live in.
We're going to be able to simulate so much chemistry and so much physics that we cannot simulate today. Things like clean energy, cleaner batteries for electric cars.
They have this tool and now they're going at light speed and they're doing things that they never even considered were possible.
We're doing this. We are solving problems today. We're not going to be told what to do by the suits, and we don't care what anyone else thinks. That's what quantum is today.
It kind of satisfies the need to explore the world. We haven't even started to scratch the surface about what these machines can do.
Thank you. So definitely it's coming soon. Ladies and gentlemen, it's time for our coffee break. We will be directed to the area where we can have our light snacks. And then we'll return here after 30 minutes to wrap up what sure has been a very good set of deliberations. Thank you very much.
So thank you. Thank you all for joining us at this special event marking the closing of the International Year of Quantum Science and Technology. I'd like to thank Ghana and UNESCO for hosting this closing ceremony here in Accra. We are deeply grateful for your leadership, your hospitality, and your commitment to the global scientific community. I am here on behalf of the American Physical Society and its over 50,000 members. APS has been honored to serve as the administrative body for the International Year. As a scientific society with a long commitment to international collaboration and capacity building, this work is central to our mission. I'd especially like to thank the sponsors who made IYQ possible. In total, there were 68 sponsors, far more than could be represented here today. But every contribution helped make this year a success. Special thanks to our founding partners, the German Physical Society, the Institute of Physics, the Chinese Optical Society, Optica, and SPIE. And a very sincere thanks to our sponsors, our leading sponsors, Microsoft and SC Quantum. We could not have done this without you. So we are all here because quantum science and technology will play a defining role in the future of humanity, from computation and communication to energy, health, and security. As has been made clear here at this conference, it is critically important that the future be globally inclusive, with strong participation and leadership from the Global South. APS is hoping to contribute through our Global Physics Summit, especially its 22 satellite sites, one of which will be held here in Accra next month. So, as the International Year concludes, I challenge each and every one of you to find ways for its spirit to continue in the days and years to come. Thank you again for your partnership, your support, and for being part of this great and global effort. Thank you.
Mr. Jonathan Bago, we're very grateful to you and grateful to your institution, the American Physical Society. And it is our hope that this kind of collaboration will continue into the future as we look forward to breaking even bigger barriers. Education, workforce, and youth-led forum. This is the focus for this final element of this closing ceremony. It will be under the topic, Preparing the World for a Quantum Future, Education, Skills, and Youth-Led Innovation. We would have 3 presentations. The first of them will be delivered by Peter Haynes of the Imperial College in London. Shall we do a big round of applause as we welcome Peter Haynes?
Good afternoon, and thank you to the organisers for the opportunity to speak today. It's been a real pleasure for me to returned to Ghana for this celebration of the International Year of Quantum, reflecting on what's been achieved and looking forward to what the next century will bring. And that future focus is the reason that education has already featured so prominently throughout this event. So in this last session, it's entirely appropriate that we focus on opportunities for the next generation of people who will shape what comes next. And I hope that when it comes to discussion, we'll hear from representatives of that generation. I can see them very visibly in the room at the back wearing wonderful T-shirts, and I hope we'll hear from them. They're not making any noise at the moment, but hopefully they will speak up later. But let me begin as well by acknowledging the context I'm speaking from. Imperial is the UK's only university that focuses exclusively on science, engineering, medicine, and business. But we were also founded to be useful. It's written in our founding charter, to ensure that scientific discoveries are translated into new technologies that bring benefit to society, that make an impact. Speaking here in Africa, to many from Africa, I don't consider myself qualified to prescribe solutions, and I'm not going to be assuming that experiences from the UK translate directly. But I hope I can offer some reflections from what we've learned within my own country and organization about widening access to education and opportunity, things that may be worthy of some consideration here. Now, as was emphasized earlier, Africa's ability to contribute to quantum science and technology is not in doubt. The challenge identified by the Africa Quantum Consortium is whether global systems are ready to recognize and enable that contribution on Africa's own terms for the benefit of the whole world. Now, at Imperial, our focus on access and skills did not begin with quantum. Half a century ago, Imperial launched the UK's first outreach programme, a mentoring scheme where Imperial students support school pupils studying science. And since then, we've remained committed to helping young people realise their aspirations, regardless of their background. Over the past 50 years, we've added innovative outreach activities through partnerships with local schools and charities, reaching around 200,000 young people in total. That commitment now has a strong international dimension as well. We recently launched the Imperial Global Network, starting with 4 regional hubs across the world. And one of those 4 is based right here in Accra. We've chosen Ghana in recognition of the wealth of opportunities here to build long-term, equitable partnerships to support research, education, innovation, entrepreneurship, and pathways into careers, working closely with the universities, governments, industry, and civil society. And we are very proud to be a partner with the African Institute for Mathematical Sciences as well, based across Africa, but also here in Accra. So our work on quantum skills sits within that broader commitment to education, workforce development, and equitable access to opportunity. Now, I've been asked to address a particularly challenging question today, namely, how might the emerging global quantum ecosystem contribute to addressing one of Africa's most pressing challenges, youth unemployment? Now, for many in this room, that is not an abstract question. You may be thinking about it personally, about what happens after your degree, about whether the skills you're developing will translate into meaningful work, and about whether you'll find that opportunity here in Africa or you'll have to go further afield. But you're also here today at this event because in some way you're attracted or connected to quantum science and technology. It is an inspirational field. Of course, that's true intellectually, but increasingly in terms of its applications. And we've heard of many at this meeting of those applications with direct benefit to Africa in agriculture, water, healthcare, and climate modeling, and so on. Now, you are part of the youngest and fastest growing workforce in the world. It brings opportunity, but it also brings pressure, because you're being asked to compete in global technology sectors that are evolving faster than education systems and labor markets. Ames contends that the next Einstein will be African, and they are a mathematical institute, so they're statistically correct, of course. By 2030, young Africans are expected to make up over 40% of the world's youth population at precisely the moment when the global quantum ecosystem will be facing a skills shortage. So what many of you are experiencing as pressure and uncertainty should be, at a global level, a strategic opportunity of historic proportion. The Quantum Insider projects that global quantum-related employment could reach around 250,000 jobs by 2030, rising to over 800,000 by 2035. But what the reports also say is that this growth is currently expected to be concentrated in the established quantum nations, the US, UK, France, Germany, China, and Japan. So it's quite right that so many speakers so far have referenced the quantum divide. It's a divide that's not only technological, but it's about skills, opportunity, and who gets to shape how quantum technologies are used. This predicted concentration of opportunity reflects the patterns seen with other emerging technologies, but it is not inevitable. On a very much smaller scale, we've seen in London that local partnerships and work within communities are much more powerful in attracting talent than remote programs run at a distance. And perhaps the self-interest of companies and countries who will be in search of skilled people might help to drive a different approach. You see, the existing educational pathways that we have only skim the surface of the available talent pool in Africa. Those in some ways who've already been able to make some access to education first. And many, of course, have to leave education earlier than ideal for various reasons. If that remains unchanged, then given the wealth of talent that there will be on this continent, then the world will miss out on an extraordinary source of capability. And as I say, that capability cannot be reached remotely. But with a more holistic approach and the right skills strategies, that could change. We've heard, starting from a young age, training the trainers, providing more opportunities on this continent, in Africa, and for Africans. This will reach a far greater fraction of the population than can be done by programs that just build on what is already here. And that population, as they are inspired too by quantum science and technology, will begin to see the change it could bring to their communities. But all that will only happen if African countries are active participants in this growth, not only for local development, but for the health of the global innovation ecosystem. Now, let's be clear about the types of skills we're talking about here, because there's good news too. These skills are highly transferable. Quantum technologies are, of course, built on deep advances in physics and maths, and that foundation is essential. But discoveries only make a difference when they're exploited, when they're engineered, integrated, scaled, and adopted. And that depends on engineers, material scientists, software developers, technicians, data scientists, manufacturing specialists, and people who can translate research into useful products and services. As has been noted, the UK has had a national quantum strategy for well over a decade, and it has been successful for driving partnerships between universities, companies, and government organizations. But there were still some gaps, some things that inevitably we missed. A need for engineers was identified early on. The importance of materials science came later. And although we have a strong national materials program in the UK, it was disconnected from the quantum program. So together with Rich Curry in Manchester, he and I set up something called the Materials for Quantum Network to bring together those research communities in materials and in quantum. And this has led to a much greater mutual recognition of the contribution that materials can make to quantum technologies. The contribution of wider skills becomes even clearer when you go into a lab, for example, that of my colleague Joe Cotter at Imperial. Joe's team is developing a quantum positioning system that works via cold atom interferometry rather than satellite signals. That means, for example, it can work underground. Joe has taken his prototype on a London Underground train. But at the moment, his device is the size of one of those air conditioning units around the room. It is somewhat limited in its practical applications. He needs engineering to make that practically useful. So the point is that quantum strategies will be strongest when they build on the full range of capabilities already present within a country or region, rather than trying to import a single model whole scale. It's been noted at this meeting that there are around 150 countries without a quantum strategy at the moment. Actually, that might be an opportunity, because there may be elements that you want to bring into a quantum strategy that are not sort of immediately focused on developing qubits, for example, but think more holistically about the skills that will be needed to take that development all the way through from discovery science into practical devices. So I hope for the students here, that is an important reassurance for you, because it means that many of the skills that you're developing, problem solving, coding, modeling, systems thinking, interdisciplinary collaboration, whether those are currently in the quantum area or whether you've got aspirations to apply them to quantum in the future, or you're not sure, those are exactly the skills that the quantum ecosystem needs. But they're also skills that are in demand across many other areas, telecoms, energy, space, advanced manufacturing. Africa didn't replicate the world's landline infrastructure. It leapfrogged directly to mobile banking and digital finance. Why shouldn't that apply to quantum as well? So learning quantum-related skills is not a narrow bet. Even if you never work directly on a quantum device, the skills you develop will remain valuable across sectors and across careers. So quantum is an inspirational topic, and the skills required are highly transferable. But quantum also rewards an entrepreneurial approach. You don't need access to expensive hardware to begin learning, as has been said already. Many quantum concepts can be explored in the cloud through open source tools, alongside computer science, engineering, or maths. And this type of training can build comfort with uncertainty, long-term thinking, and systems-level problem solving, all of which are essential attributes for entrepreneurship. And that matters because job creation is unlikely to happen in core research or even through big companies on their own. As we have seen, there is a multiplicity of smaller startups that are playing an increasingly important role in the quantum space. So in Africa, as elsewhere, it's predicted that opportunities are likely to emerge downstream in quantum-adjacent software, data modeling, and applications across health, energy, logistics, finance, and telecoms. This is where those startups, small and medium-sized enterprises, are most likely to form. And some recent investments reinforce this point. The establishment of a new optics and photonics laboratory in Ghana, supported by the Society of Photo-Optical Instrumentation Engineers, SPIE, one of our sponsors, demonstrates how interdisciplinary skills development can underpin quantum technologies while also strengthening closely related sectors such as telecoms and advanced manufacturing. These pathways offer agency. They allow you not to just wait for opportunities, but to help create them for yourselves. And that brings me to an important transition. Education is essential, but as we've already heard, it is not sufficient on its own. Without awareness, inclusion, informed policy, and pathways to impact, training alone cannot deliver opportunity. For skills to translate into employment, the jobs must exist. That requires enabling conditions, government policy, sustained investment, informed regulation, and environments that attract entrepreneurs. Preparing for a quantum future is therefore not only about training the next generation of scientists and engineers, essential though that is, it's also about helping users, investors, regulators, and policymakers understand quantum technologies well enough to engage with them confidently and to be intentional about ecosystem design. This includes quantum for health, working with clinical medics, quantum for finance, engaging with regulators, and quantum for investors and funders, including venture capital and national funding agencies. At Imperial, my colleagues, led by Jess Wade, have addressed this through our Quantum Fundamentals program. So this is a training course, but it's not for traditional students. It has versions for civil servants from our government, a different version for policymakers, for regulators, for investors, and for senior decision makers. And its purpose, of course, is not to turn them into quantum scientists, but to enable informed decision-making, decisions that shape funding, regulation, procurement, and ultimately the availability of jobs you may apply for. The most enduring legacy of any technology revolution is never the devices themselves, but the people it trains, as we heard from Joe first thing this morning. To the students here today, you do not need to have a single fixed career plan. In fact, that is impossible. No one has ever had one of those. But many of the challenges we've discussed are real, but they are recognized. And what matters is developing skills that are challenging, transferable, and future-facing, and seeing yourselves not only as future employees, but as future creators. Quantum is a great place to do that. So please remember, you're not waiting for permission to belong in this future. You already do, and it is you. Thank you.
Thank you so much. Ladies and gentlemen, we'll open up for 2 questions, and then after that, we'll move on to the next presentation. 2 questions, and just in case there's a question, you mention a name, mention your institution, and go ahead with your question. Very brief and straight to the point.
Just to break the ice, and I'm sure others, it's more a comment and a request, a call. I was very intrigued about the training that your college is developing for civil servants, policymakers. Can we discuss how to make it available to other countries? Because I think you are absolutely right.
Yeah, absolutely. I think we would be delighted to do that. Just to be clear, I think we're just starting a third edition for the initial version that was for civil servants. So we've had a lot to learn, because we do span a very broad range of things, and while these are very interested, very intelligent people, they also are they do not have a science background necessarily. So there's a lot of fine-tuning to do, but having sort of got that one ready, now we've sort of rolled out the ones for other audiences as well. And so, yeah, I'd be delighted to have a conversation about that. And I know my colleagues back at Imperial will be very keen to as well.
Yes, my name is Silvina Ponce-Dosum. I am IUPAP. I also wanted to ask you about the course. I guess you started recently, but what's the impact you are having? How it's being received? How many people apply? And I would like to know a little bit about that.
Yeah, so I did give a talk in the first edition of it, so I could see that there were about 30 civil servants for that first edition, following a call across sort of government departments. It then sort of, I was successful in sort of generating the same level of interest for a second edition. The pinch point came when actually we also then decided that we would start to charge a little bit of money for the UK, for the UK government at that stage, and the interest has maintained. So it sort of made that transition, if you like, towards sustainability and the ability to cover its cost. The feedback has been positive. We have, and constructive as well. So it's been a very exciting time. I mean, we call it Q Fun, and it is great fun. Being able actually to engage with people from wider society beyond sort of academia and industry in the opportunities of quantum is actually an incredibly rewarding thing to do.
Thomas Conrad from the University of KwaZulu-Natal in South Africa. My question revolves about the circulation of young talents. You told us that there is a lot of young people in Africa, and there will be a lot of talent that we must not miss. How can we make sure that the talent, once it's educated maybe elsewhere, returns? Does it not depend on the opportunities that are given in the states where the talents come from? How do we make sure that we create these opportunities at the same time as we educate them? Thank you.
Yeah, thank you very much indeed. And I think that's a great question, isn't it? And really has been at the hub of the discussions, over these 2 days. Yes, we're not looking to train up people from Africa, then to have to go to the global north to get a job and not to return. We want the opportunities absolutely to be here. There were interesting things yesterday said about, a pathway to that, perhaps through the resale, the assembly, the manufacture of infrastructure within Africa to make sure that that is available here. I thought that was a strong point because, of course, we can imagine an end point and we can see where we are, but it is how do we get there? And I think that's where I would want to say, look, there is this role for equitable partnership, by which I mean, as has been said today, the co-creation of initiatives in education and so on, and that is for everybody's benefit. What I'm trying to say is that if we don't get training and education right in Africa for quantum, and it applies to other sectors as well, then the world as a whole will be missing out on that talent. And I really think, it's fantastic the efforts that are being made, but they are only skimming the surface at the moment of the potential that I think there is there. Thank you.
Thank you. Thank you very much, sir. Ladies and gentlemen, can we appreciate Mr. Peter Haynes? Provost and Vice President of the Imperial College in London, we're very grateful to you. And now we'll go to our next presentation, which will be the last but one for today. While we do all of this, I would like to remind all of us that participants are, welcome to a cultural visit, and this is specially reserved for our international participants, our visiting participants. And remember that all you need to do is just inform the information desk and give out your details, and you'd get yourself ready for the bus, which will be parked at the main entrance of the hotel. Ladies and gentlemen, at this time, would like to invite Dorcas Etwebia Ado, and she is from the University of Education, Winneba, bringing her perspective to the conversation. Shall we welcome her with a big round of applause? Dorcas Etwebia Ado is from the University of Education, Winneba.
All right. Thank you so much to the organizers for the opportunity, and thank you all who made it possible for me as well to be here. Yes, indeed, there is a lot of talent in Africa, and we keep talking about the great talents we have in Africa and how to build this talent as well. So my talk, basically, it's looking at we require new ways of thinking. With the basic skills in technology, with the complex as well, we need to prepare ourselves so that we are not left behind. All needs to be included in this new digital divide age. Yes, we admit there are a lot of barriers, there are challenges as well. A lot has been said here in terms of foundational education gap. I mean, you notice that from the basic level to the tertiary, at the basic level, quantum science and technology is not mentioned in our curriculum. Even in the tertiary, not all institutions are doing quantum science and technology. So we have so much gap that we need to cover. And this is a time where curriculum developers, the Ministry of Education, and all involved will have to come in so that the gap we are talking about today can be discussed, can be looked at, and to see where and when do we incorporate into our curriculum. There is the infrastructure constraints as well. Yes, a lot has also been said about us, but the infrastructure constraints here is not just about the building. It's not just about having the quantum hardware we are discussing today. It's about the capabilities of the youth as well. If we have that kind of capabilities in terms of that infrastructure, then the youth can go ahead to co-curate, co-develop, and the infrastructure in terms of the building can also happen for us as well. And there is funding opportunities as well. There is a youth today who is very interested. Today you are quantum aware because you happen to be seated here joining the closing ceremony. The question you are asking yourself is, how do I move on? How do I be part? Even at the tertiary institution, after the undergraduate level, how do we encourage our students to do graduate studies in this field? It's all about the opportunities in terms of funds as well. That has also become a gap for us. So even though Africa has the talents, we still send them to the global north as well. And when they are done with their studies, the opportunities are there for them to stay and work. So the talents we build are all gone. But then, should these funding opportunities be available, we will work harder. There are gaps. We get it. We understand. We understand everything you are saying, even within your hearts. All this gap exists. That also does not mean we can make impacts, because there are cloud platforms for us now that we can start with. We can start with our simulations as we think about having a physical quantum hardware in Africa or in Ghana. We have access to the cloud. We have the skills as well. When the skills are there, we will have the machine. So we are saying, let's educate the youth before thinking about the hardware. If we have the hardware and the youth are not skilled enough, how do they create? How do they develop as well? Then we can move beyond the legacy technology we are discussing today. We all have equal opportunities today to innovate as youth. So then I'm saying quantum is not an equalizer, not because it is cheap, but because it is accessible, open, and skill-driven. The education and skill parts for the youth as well has gone beyond what we already know. And sometimes we think that the basic does not matter anymore for us. So you might be saying that you are reading computer science, you might be reading chemistry or engineering, and you might be thinking that this whole quantum is for the physics people. No, it's not just for the physics people, but then it is for all, depending on wherever you find yourself. It is equally important that in the education system, we talk about our computational and system thinking, which is very essential for this technology, have the problem-solving skills we need, and the mathematical modeling as well. So we have institutions like the African Institute for Mathematical Sciences who are also developing talents in Africa as well. In as much as we encourage, in as much as we educate, there is the need to talk about the ethical use of these quantum technologies as well. How responsibly we can guide the youth to use these quantum technologies. We are saying that learning must move from consumption to curation now. You have passed that stage. Now you need to make an impact with whatever you have studied. You are the innovators. You are the co-curators. You are not the beneficiaries today as a youth. So there is a need to actually come together, work together, collaborate among ourselves. We talk about collaboration, but all the collaboration that has happened here is how Global South can collaborate, can partner with the Global North. How about collaboration within ourselves as Africans, collaboration within ourselves as Ghanaians, and even among ourselves as youth? If you are in math and I'm in physics, why don't we come together and collaborate to innovate what we want to do? We should have youth-led communities that are sustained on innovations that we are talking about today. What does the future then look like for us in Ghana as we talk about quantum science and technology today? We are saying that the future for Africa is quantum literate youth. Quantum literate youth first. And that could only happen through the educational system, whether formal or informal as well. And we need to include all gender inclusive. The gap is still there for the female. The gap is still there for the young child as well. So as we celebrate the International Day of Women and Girls in Science today, we are saying that let's include the young girl. let's include our women as well. Then the youth will shape the technology we are talking about. No youth should actually be left behind. I guess you are wondering, if no youth should be left behind, where do I start from? This is where you start from, by joining communities, by joining learning platforms. There are a lot of learning platforms like the IBM learning platform, the Penny Lane, the QBraid, and a lot of learning platforms. There are lots of communities as well, both locally in your country and in Africa as well. We have the Q-World. Q-World has a lot of learning structure for the youth, from quantum science to computing to technologies. Why don't you join that community so that you start from there? We have the African Quantum Consortium, there's Quantum Africa, and even in Ghana here, we do a lot under the Mathematical and Computational Physics unit. In physics, we engage the youth through outreach programs and other activities like workshops and seminars. This is where you can start from as a youth today. Preparing the world for a youth, for a quantum future, actually starts with you, the youth, with me, and all here. Thank you.
A very grateful to you. Now, ladies and gentlemen, we'll see if we have some questions. And as usual, the drill is to mention your name, your institution, and go ahead with your question. Would make room for 2 questions after this presentation.
Thank you. My name is Max Madanzi from AIMS, and my question is, we've been talking about quantum for the past 2 days, and the main issue that I want to address is how practical is it for the youth? Because we talk about quantum, we talk about all these things, but what example are we giving to a young person walking on the street that, oh, this is a product of quantum knowledge, or this is what quantum has been able to produce? Because I believe that the reason why STEM has been more accessible and interesting for you to delve in is because they see the importance of it. Now, every young person has a mobile phone. And so the question will arise, how was WhatsApp, created? How was it developed? And that really encourages them to go into software development. Now, my question is, how practical are we making quantum knowledge amongst the youth that would interest them to delve into it? Thank you.
Thank you.
All right, thank you so much.
Thank you very much. My name is Jerry John from the Kwame Nkrumah University of Science and Technology. I just want to pick it up from where the last speaker left off. And that has to do with translating theory to practice. I mean, previously we've walked this path before, where when it came to computer literacy, for some communities, they were using stones and others to try to explain to the students what a computer looks like. There is a lot of talk about quantum, but as has already been asked, how do we move from theory to practice? How do we ensure that in our various schools, we are able to give students a practical feel of how quantum looks like?
All right, thank you so much for your question. Yes, the question you asked is so great. I mean, that is why we are here today. And that is why you heard from OQI about use cases. Last year when AIMS organized the Quantathon, it was about use cases. It was about showing real life application of quantum science and technology, real life application. Where can I apply in terms about the practicality? Where do I apply quantum science and technology? And through this education, through this quantathon, hackathons, you realize that quantum can be applied. Let me use our current galamsey issue in Ghana we are facing now in terms of water quality, in terms of, getting clean and equitable access to water. You notice that some of these algorithms we are building, we are talking about, can actually be used to solve some of these cases for us. Quantum has not advanced so far. Yes, we accept, because there are lots of research as well that needs to be laid to. But then, in terms of these use cases, in terms of simulation and other things, we get to appreciate that, yes, this is what quantum can do. So why don't we start from there instead of always discussing the practicality? Why don't we start from appreciating these use cases, that this algorithm can be used to solve this problem? If this algorithm can be used to solve this problem, then you and I can think about to wait for anyone anymore. If you are in an institution where quantum science and technology is there, is being taught, and there are students groups there, you should get involved. And when you also get involved, that is where advocacy also starts from. You can as well also talk to others about quantum science and technology. So share the link, share the knowledge. The more you share the knowledge, the more you talk about it, then more people are also involved as well. Most times we get afraid talking about the course we know or even the knowledge we have. But then the more you talk about it, the more you get engaged, the more you plan to organize workshops and conferences for the local people, the more we get to spread the news. The more you decide to join me and the other team members to go out to the senior high school to preach quantum science and technology, the more the future becomes brighter for the young ones as well.
Thank you. This will be the final question. Thank you.
All right, thank you very much. My name is Godsway from the Ghana Digital Centers. You spoke about youth readiness as a prerequisite for quantum science and technology. Now, what I'm trying to find out is, what are the practical steps that Ghana can take to start closing the skills gap whilst major curriculum reforms are in process? Thank you.
All right, thank you so much for your question. That is beautiful. I will not try to answer that question because UNESCO is here and they have the basic sciences and research, so they assist with governments as well in terms of areas like that. I will not try so much as well because NACA is also represented here. Then the Ministry of Education as well is also represented here. So the next step is stakeholders engagement. Thank you.
Thank you very much, madam. Shall we do a big round of applause? And to wrap all of this up, I'll take a brief insight from Dr. Prince Osei of AIMS, to the specific question about practicality and how the youth can get involved. Doc.
Thank you very much. I think I will not say much. I'll leave it to the next session because the students who worked on our hackathon demonstrated how a quantum code can help create a drug for malaria. So this is one practical example that I'll leave the team to demonstrate. But there are several examples. She spoke about using quantum sensing for responsible mining, environmental sensing, and so on. So I'll just stop here and then look forward to the next session. Thank you.
Thank you very much, Dr. Prince Osei. Ladies and gentlemen, our final presentation for this conference will be from Angela Tabri of AIMS. She also brings another perspective to this. Shall we do a big round of applause as we welcome her? Can we have the introductory video play now? Thank you.
This week, we have been holding a quantum technology education event, a hackathon of quantum technology hackathon, which we refer to as a quantathon. We have also been having a workshop on quantum technology education, discussing concepts and ideas of training young talents in quantum science and technology from high school all the way to the university. We had some exciting discussions in the workshops in the past 2 days. There was like prize for Martin to announce. But before that,
in progress.
the winning team is Valeria.
Thank you very much. As highlighted this morning during the first panel, today is the International Day for Women and Girls in Science by Sylvina in the first panel. And I'm very delighted to share the vision for this year is from vision to impact. From vision to impact, closing the gender gap in STEM. And I would like to highlight one of our flagship programs at AIMS Ghana. So a few years ago, we had a vision at AIMS. And what was the vision? We wanted to create this pipeline for young high school girls in Ghana who were talented in mathematics. Nurture their talents in the mathematical sciences through online interactions with world-class scientists, through mentoring by world-class women in STEM, and also residentials where they come to our center to engage in hands-on mathematics. And after about 5 years, we've seen the successes. And I'm very delighted that we have one of our alumni, Dorcas, who was in the winning team for the Quantathon, who will be presenting to us one particular solution. But I'd also like to highlight some of our alumni who are here as we celebrate our women and girls. So we have here Maxima, who is electronics and electrical engineering graduate from KNUST. Can we give her a little round? Then we have Salima here, who is just graduated with a BSc in mathematics. Thank you, Salima, and Dorcas will be coming. So I'd like to invite Dorcas on stage, who just graduated with a BSc in physics, who will be giving to us a quantum solution to malaria. And afterwards, we'll have a brief fireside chat, and that will be our session. Thank you.
Well, she has said it all. Good afternoon, ladies and gentlemen. So recently, we keep hearing incredible news. Breakthrough drugs for cancers once thought untreatable. Humanity is really pushing the boundaries of what is impossible. And then there is malaria, a disease we have known for centuries, a disease we understand, a disease we can prevent and treat. Yet every single year, hundreds of millions of people are affected. And Africa carries about 95% of the deaths happening as a result of people contracting malaria. So the uncomfortable question is, with all our modern science, why are we still losing so many lives to malaria? Welcome, ladies and gentlemen, and I present to you Quantum Leap Against Malaria. So at the heart of malaria's persistence is a major challenge. Drug discovery is slow. So finding a molecule that can effectively attack this malaria parasite can take many of years and even exhaust billions of money. Meanwhile, the parasite keeps evolving, hence gaining resistance. So as Team Qualaria, we asked ourselves these important questions. What if we could accelerate finding these drugs faster? Or what if we could find a smarter way of getting it and not taking longer to get the anti-malarial drugs? Why now? Why quantum, you may ask? Well, quantum because molecules are quantum systems. So to predict how drug will bind to a malaria protein, we must understand interactions at the atomic level. So basically, quantum computing helps us model these molecular interactions exponentially faster than the classical computers. And they help enable chemistry simulations that classical computers cannot handle. And they are perfect for protein ligand binding prediction. What then is our goal as Team Qualaria? Our vision is to help reduce deaths by accelerating the identification of the potential ligands for the dominant strain of malaria. So as a use case, we used one of the deadliest malarial parasites which affects over 98% of people globally. That is Plasmodium falciparum. In using quantum computing to solve it, we used the variational quantum eigen solver. So think of it like a super intelligence filter. So first of all, we generate the 3D structure of the malaria protein. Next up, we identify the active binding pocket. Then we use our algorithm to simulate the molecular binding energies. So our main focus is on the molecules with the lowest binding energy, meaning that they attach best and have the highest potential to work as anti-malarial drugs. Instead of blindly testing millions of options in a lab, we let quantum computing narrow the field. Less guesswork, less cost, and much faster hope. So Qualaria is building a platform where pharmaceutical companies can license promising candidates, universities and researchers can run simulation, and global health organizations can collaborate to accelerate innovation. Our roadmap includes expanding on quantum data set of the malaria protein structures, deploy on a hybrid quantum cloud like IBM Quantum, secure over 500,000 seed funding for our MVP. We also plan to scale our solution for other diseases as well. Please meet the team from Print. We have Augustina, which is somewhere around there. Augustina, can we see you? Yeah. And then there's me, Abibu, and Astride. So in conclusion, this ceremony reminds us that quantum is not only about theory, it is about transformation. It is about taking the most advanced tools humanity has and pointing them towards problems that truly matter. So at Qualaria, we believe Africa must not stand on the sidelines of the quantum revolution. But first, we must use it to protect our people. Thank you.
Dorcas. So we will have a brief fireside chat. If there are any questions, but you will take it at the end of our session. Thank you. Okay, so we are in the final section of our session here. So good afternoon once again. In the speech by Peter Haynes, there was reference to AIMS as we having the tagline of the next Einstein initiative. I need to highlight that we have transitioned from that to in Africa's youth, the future of science. Why? Because we all heard from the statistics, and in a few years' time, we will have a lot of young people being African. And at AIMS, we believe that we need to create those opportunities for these young people in the sciences. So for decades, Africa has played a lot of catch-up, right? But now, in this quantum age, we are not going to stand on the sidelines. We are going to be the architects of this quantum revolution. And joining me for this discussion are three visionaries, Abdul Majid Osmanu from AIMS Ghana, who will be our quantum educator, Augustina Jimain, who will be our innovator, and Estelle Inak from Perimeter Institute, who will be our policy advocate. Can we clap for them as they take their seats, please? Thank you very much. We are going to be brief, so don't when your session is before lunch, everyone is in a hurry to go. So we are going to be brief. So to my panelists, if the future of science is truly in the hands of the youth, right, who are sitting in this room, watching online too, why is quantum the frontier we must claim right now?
Okay, thank you very much, Angela. Why quantum is a frontier now? Well, one thing is quantum is not a classical plus. So it's an opportunity, or it's a leapfrog opportunity that we have to make use of. And so in that case, we can't go ahead still in making use of the 20th century legacy systems to be able to understand or make win of 21st century science. And so how do we do that? We need to teach what we call the spinning coin metaphor. And so to the audience or to the youth here, just take a look at, say, classical bit. It's like a coin on a table which has a head or a tail. And so when you go to the quantum world, which is a qubit in this case, it's like a coin that is spinning, and so you have both ends. And so you can only be able to measure it, afterwards. And so in that case, we want to be able to, teach the youth, okay, let them be able to think in this spinning space. And so if they're able to do that, then it means that they're able to out-innovate anybody who is stuck in the binary world. Yeah.
Thank you. But we live in Africa or Ghana where schools are struggling with their basics, right? So some schools will not have a proper structure, will not have access to computers, right? Or even access to the basics. How do we make sure that we are getting everyone involved with the right tools in this quantum age? Yes. Augustine.
Yes. So this is about quantum justice. So we have to make sure that our youth have access, first of all, in the near term, to high-speed internet so that they can at least experiment with quantum emulators, quantum simulators, and of course, quantum computing on the cloud. But ultimately, in the long term, I think Africa should think about African sovereignty in quantum, on the IP, on the whole quantum value chain.
Thank you, Estelle. That was very concise. Our innovator, Augustina, let's talk about the real world, right? As Maxima said, we want real solutions. What is a quantum African problem that you want to see solved?
All right, thank you very much. So I really like the image of the mist in the maze, right? So for me, I think of African challenges like that of the maize. Now, we have the maize as the African challenges. Then, a classical computer enters the maze, right? It enters the maze as a mouse, hitting all the walls one after the other just to find the exit. Now, here comes the quantum computer. So the quantum computer enters the maze as a mist, and it simultaneously finds so many possibilities or so many solutions, and eventually finds a solution, the best solution. So with this mist, we can use this mist to solve so many problems here in Africa. So for example, like the cholera, we can use this mist, like the quantum computer, to accelerate the identification of potential ligands for the dominant strains of malaria. So with this, it can help us solve so many problems. So for the youth here, or anyone listening to us right now, we don't need to wait for perfect hardware. We can just build on the skills that we have or learn more online. We have a lot of resources there, and just wait for the perfect hardware.
Thank you. So what do we need? What tools do we need? Majid, can you help us with some practical tools? Do we need very high-speed internet? What if we don't have these computers? What tools do we need? Can we start with?
I think in our context here in Africa, I think a phone is okay, and also you need a platform like Qiskit. And so if you can code, then what it means is that you can definitely start quantum thinking tonight. And that is enough for you to go on to start doing your quantum stuffs. Yeah.
Thank you. In our penultimate round, I'll go with you, Estelle. What is the biggest lie people believe about quantum in Africa?
Well, we believe that the cloud is open, which is not. For everybody who tried to, buy quantum, I think it was Prince who talked about they had a bill of 50K, right? The other lie is, I heard it across the board, it's too expensive for us, especially the experimentalists. No offense, guys, but let's try hard, Let's lobby hard, the governments. I've not heard about African VCs. Where are they? Or angel investors, right? Let's try hard. And the brain power is free. We talk a lot about our talent. It costs to train them, right?
Thank you very much. To our innovator, Augustina, what do you predict will happen in 2035?
Okay, so in 2035, I believe we'll all see an African-led teams coming up with solutions, quantum-inspired solutions to solve most of the SDGs here in Africa. And so we need to learn more, learn hard, so that we can attain a better free future. Yeah.
Thank you. And to our quantum educator who is really breaking down the jargons, let's say a 16-year-old is either sitting here or watching us online. What is their first step?
That's a good question. And so from the university's students that we have here, I'm sure most of them have done a bit of or linear algebra. So you need a linear algebra for a start, and also some Python. So if you can code linear algebra and Python, that's your sure way ticket to go.
Thank you. In your closing remarks, I would like you to give a message to women and young girls as we celebrate International Day for Women and Girls in Science. What is your vision and for how we can close that gender gap in STEM? So anyone can start. Your closing, yes.
Thank you. So I think my message or my closing remark will be that the quantum technology is still being written. And so it's imperative that we ensure that women are part of this progress, because it's just not been about fairness. It's about trying to build a better system, a better future, and also better companies when we involve women.
The hard way of the quantum revolution is in the talent and ambition of the young people either sitting here or watching us online. At the African Institute for Mathematical Sciences, AIMS Ghana, our vision is simple: in Africa's youth, the future of science. Today, we have realized that the future is not just a date on the calendar. It is a mindset. It is a refusal to wait for permission to innovate. It is the courage to master the most complex science of our time, because we know that our communities deserve the most sophisticated solutions. The quantum era will not be defined by those who built the first computers, but by those who use them to change the world. To the youth here, the lab is open, the code is waiting, and the future is yours to write. Thank you to our panelists, and let us go and build that future. Thank you.
The future is yours. Let's go out there and build it. A great and inspiring message for the youth of our country and the youth of the world. Shall we do a big round of applause for them one more time? Before the closing remarks for this conference, I would like to get further knowledge and a lot more insight into the Global Quantum City Prize. I'd like to welcome up here for a 3-minute explanation, Yasser Omar.
Sure, so I'll try to be extremely brief given the late time. So, yes, so in the context of the International Year of Quantum, the Quantum City Prize was organized. This was a prize stimulating activities, raising awareness about quantum science and technology in a public space of a city. So instead of a lab tour, a colloquium, an exhibition, you had to be creative and bring quantum to the people. And so we are very happy, and this was sponsored by the International Year of Quantum. We're very happy to announce here the winners in each continent and then the global winners. So I'll try to go very fast. Sorry, I will just read given the late time. So maybe I can get this. In Africa, the winner was Alamein City in Egypt with their project Alamein City, the Past and the Future, organized by the International University there and the Alexandra University there. In Asia, the city was Osaka in Japan with their Osaka Quantum Discovery, organized by the University of Osaka. In in Europe, the winner was the city of Putignano in Italy with the initiative Quantum Paradoxes in Papier-Mâché, and this was organized by the Institute for Photonics and Nanotechnologies. In North America, the winner was Urbana-Champaign Twin Cities with the Public Quantum Network project organized by the University of Illinois at Urbana-Champaign. And in South America, the winner was the city of Paraty in Brazil with the project Entangled Perspectives by the University of Rio de Janeiro. So we don't have time to show you the photos and the videos, but all of this will be made available online. These are really, really interesting projects. Out of these continental prizes, we wanted to choose one global quantum city. It was very hard for the jury to decide, so we exceptionally awarded 2 prizes. The first prize out of these 5 was to the project in Italy, where they brought quantum to the carnival parades and sculptures in the city. And the second prize, also excellent project in Egypt, in Al Alamein, where they just went on the street and started interviewing people. What do you know about quantum? Come and discuss with us, come and play with this game on the street. So sorry for taking so long. Congratulations to all the winners. Thank you very much for the organizers. Thank you to the International Year of Quantum for the support. By the way, thank you to Richie Mike Wellington and his team for putting all this together. Thank you so much.
Thank you very much, Yasser Omar. Ladies and gentlemen, the last international event I hosted was in Alamein City in Egypt, and the general look and feel there gives you the sense and the feel that the authorities, the government, and the people have very much embraced quantum and how it can be immersed into our society and practicality and the everyday things that we live by. And of course, you see a lot of infrastructure in Alamein, you see a lot of the use of technology, and of course you see modernity, meaning that this was a very, very crucial place for this event to be held. We're grateful to you, Mr. Yaseromaya, once again for bringing us, that very important update on this. And now, distinguished ladies and gentlemen, it's my pleasure to welcome here to the stage for our closing remarks for this conference, Professor Osman Damba, who's the Secretary General of the Ghana Commission for UNESCO. Please welcome him with a big round of applause.
Thank you. In fact, let's clap for ourselves. I have the difficult task of bringing this successful event to an end, and I wish we could continue, but then every successful journey comes to an end. I mean, for the past 2 days, we've been able to demystify the term quantum, moving from theory to practice, and I'm sure living here, each stakeholder, each participant here knows to what extent he or she can actually benefit and be informed about the word quantum. Thank you. Your Excellencies, the Assistant Director General of UNESCO, leaders of the international scientific unions and academics, honorable ministers and heads of delegation, distinguished members of the scientific and diplomatic community, ladies and gentlemen. As this global closing ceremony concludes, the Ministry of Education thanks all participants who contributed to this important gathering. Over these past days, participants have shared insights, perspectives, practical experiences. These discussions have highlighted both the progress and achieved activities during the International Year of Quantum Science and Technology and the work that lies ahead. The International Year has strengthened global awareness of how advanced science connects with education systems, research institutions, and future skills for development. It has also reminded the young and upcoming scientists the kind of preparedness that is involved and the confidence that is required to move the quantum debate forward. Ladies and gentlemen, Your Excellencies, the Ministry of Education continues to prioritize scientific literacy, quality teaching, learning environments that will nurture talent. Strong educational systems will create the foundation for scientific advancement and innovation. Your Excellencies, distinguished guests gathered here, we acknowledge UNESCO's leadership in guiding the International Year of Quantum Science and Technology and the role it has played in advancing science as a public good. We also recognize the contribution of the international scientific community, development partners, and the national institutions that have supported this conference and ceremony. Ghana values the partnership strengthened through this process. The continued cooperation among member states, educators, and the scientists remains essential for expanding knowledge and opportunity. Distinguished guests, Your Excellencies, as the International Year formally concludes, collaboration must continue. The exchanges held here in Accra would inform the future in science, education, and technology. On behalf of the Honorable Minister of Education, Honorable Haruna Idrisu, we thank all delegates for their participation and commitment. We also commend the organizers and the technical teams whose work has ensured a successful event. On this note, I wish to thank members of the planning committee, Richard Magulentin is here, Professor Drew, who is not present here, my own good self, members of the Ghana Commission for UNESCO, the UNESCO Field Office, for putting up this wonderful event. We wish all participants safe travel and continued success in all your endeavors. Thank you. Just need 1 minute of your time, and we call on the ADG for UNESCO, Brito, to come up stage. Mr. Mukala, can you join? Unless Kente was listed as one of the products of UNESCO for Ghana, and we want to show appreciation to the ADG for honoring this important conference and program. So, Your Excellency, Lydia Brito, Ghana just wants to show appreciation for spending time with us in Ghana, engaging with the various ministries and agencies, and reinforcing Ghana's commitment to seeing science education leading the process to our national development. And in our engagement yesterday, Mr. Mukala and myself, we reinforced Ghana's commitment to the goals and ideals of UNESCO. And so based on this, we want to show appreciation for your continuous commitment to Ghana's process and seeing science education taking the lead in our national development. So thank you very much. And this is called, yes, and this is called Kente. You can use this on special occasions. Sure.
Yes, yes.
So it matches. It's as if we knew what the outfit of the ADG. Thank you.
That's why I use red today.
Yeah, sure.
Your Excellencies, distinguished guests, ladies and gentlemen, this show has been a very exciting 2 days. 2 days of brainstorming, 2 days of giving various angles to the very big story and the movement of quantum science and the role it plays within the bigger picture of the world's continuous story. As you and I depart Accra, Ghana, it is our hope that the next time we converge as a collective, we would have moved the stories further. The beautiful thing about it here in our jurisdiction is that there is the very heavy participation of academia. Academia represented by some educational institutions, including the Kwame Nkrumah University of Science and Technology, who will be at the forefront of moving the story forward in terms of the next generation and how this story will be continuous. The appreciation of quantum science is very simple. It is about having a generation who believe and understand the true role of quantum science and what it does within every sector of our lives. It is also about seeing that the human beings who now understand quantum science make sure that they create the needed environment to make it thrive and make it a key element within what we're doing as a collective. From all of the deliberations we've had here, it is very clear that the future is bright. The future is bright because quantum science has a very big representative voice in you and I. And as I said, we look forward to the next time when we all converge again, because there sure will be some exciting stories to share. On behalf of the whole organizing team here, the Ministry of Education, has been said by Prof. and the whole team, everybody who took part here, we say a massive thank you to all of you. Would also like to say a very big thank you to the management of Labadi Beach Hotel, who have made this place home to all of us over the last 2 days. It is not by accident that Labadi Beach Hotel is always winning various awards in the hospitality industry here in Ghana. What is left of the afternoon and what is left of our stay is to experience some more of Ghana from outside the walls of this place. And so based on the amount of time we spent here, we look forward to seeing us move with the bus at the front from 3:30 p.m. exactly. So we'll be glad that all of you are able to get done with lunch as early as possible so that we can all, make it as part of this cultural trip and this experience. Once again, would like to remind all that this is reserved solely for our friends who are visiting from outside Ghana. Once again, my name is Nathaniel Atto. I've not been doing this alone. I did this with my and also our language translators and a very, very competent and hardworking technical team, most of whom are in the background and working things from the back end. We need to congratulate them. And also, once again, to the National Ambulance Service, who have been here with us from the very word go. We're very grateful for your professionalism, your sacrifice, and your alertness. We very much appreciate that. And so once again, on behalf of the whole family, on behalf of Prof. Damba, the whole team, and the organizing teams that were put together, we say we're grateful to you, and we look forward to seeing you sometime again in this beautiful city of Accra, Ghana, Ghana being the center of the world. My name is Nathaniel Atto. I thank you all very much. God bless you. And finally, once again, would like to take one very big photograph. So like we did last night, we'll have as many of us as possible join here on the stage and some down here for a very big photograph. Thank you very much.